So what should we do? So then what did we learn in the pure semiconductor? We took an example of a silicon, right? Yes. From where do we extract silicon? Sand, right? So sand was, as ma'am was asking, that if I need to show somebody that what is silicon, then sand is the best example, right? So let us say that we have sand, and then we look at the structure of the silicon. So the silicon was having how many valence electrons? 4 valence electrons, right? So when we are bringing the silicons together, they were forming a covalent bond, and as a result, the Fermi level was somewhere in the center. Understand? Now what we need to do is that when this is exactly at the center, we can say that there are equal number of electrons and equal number of holes over there in the pure form of semiconductor. From this one, now we want p-type, so which means that now we want more positive charges to be over there. So then what should we do? Because we were having silicon which was having 4 valence electrons, right? Yes. But over here for the p-type, we were having boron, which was having 3 valence electrons. And for n-type, we were having, let us say, phosphorus, which was having 5 valence electrons. So now what will happen because of that? So that is what we discussed yesterday, right? So when we are adding boron as the impurity to the pure semiconductor, because there is 1 electron which is missing, we can say that if we keep on adding more and more number of borons, the overall charge will become positive. Understand? So that is what we are going to start with, which are the charges. So charges, there are 2 types. One is positive charge, another is negative charge, right? So this p-type and n-type, which is negative and positive, they'll ultimately be called as charges, right? And especially this p, positive and negative itself. The n-type and p-type, they are the semiconductor materials, but I'm currently talking about the charges on its own, which is plus and minus. Understood? Where your plus, they are known as holes, and the negative one, they are known as electrons, right? So from this, we are first going to do one experiment, because I want you to understand that how these charges work, right? So all of you have the plastic ruler in your kits. All of you have the plastic ruler in your kits? I'll turn off the fan, because what needs to be done is it's not turning off? Yeah, I already did all of them off. Maybe it is connected with some switch directly. Okay. Right. So you have ruler with you, right? Which is this kind of ruler you have. Now take one paper. See, we don't really want to make the class very messy, but then I want you to make the papers in a very small pieces, right? And then what I want you to do is you rub the scale on your hair and see, and then you bring it near the paper. What will happen? Have you done this experiment? Yes. If you've done it, then don't worry. Yes. I was under impression that you have not done this experiment. So if you've done it, that is excellent. So that will make my task very easy. So now, can anyone tell me what exactly happens, especially keeping the charges positive and negative, right, in our mind? Let us say when you're not rubbing your scale, when you're not rubbing the ruler on your hair, and when you bring it near the paper, nothing will happen. Yes? Yes. All of you agree with me? Yes. But now what happens is, you rub the ruler to your hair, and then when you try to bring it near the piece of the paper will start to get attracted to the ruler. So then something is happening. So now we need to come up with a conclusion, and especially we want to learn something about electrostatic force. And why we should understand electrostatic force is because the next topic which I'm going to teach you, that is p-n junction diode. And when we bring, because we already have a p-type material with us, we have the n-type material with us. We need to now know that what will happen when we bring this p and n together. So if we bring it together, something is going to happen. But we can only understand what happens if we understand this practical clearly, right? So for that, now let us say that what will happen if we have So I want you to tell that which one I'm bringing positive charge together, negative charge together, and a positive negative charge together. I want you to tell that which one will attract and which one will repel each other. So it's like this, that let us say this is positive, this is also positive. I want you to tell whether this two will attract or this two will repel each other. If I have two negative charges now, again I want you to tell whether it will attract each other or repel each other, and then one is positive and another is negative. So what will happen? Will it attract or repel? So let us first try to fill this up. Positive, what will happen? It will repel or attract? It will repel. Very nice. What about negative? Repel?
Yes.
And positive, negative? Attract each other, right? So this is one of the laws of the electrostatics, that like charges repel each other while opposite charges attract each other, right? And that is what we are going to use. Now, just understand one thing. Because we have p-type, so just consider that this particular block of the semiconductor which we have, that is filled with all the positive ones, right? And this n-type, this is all negative. Or we simply use something like this. Instead of that, I'll make it better, because when I bring it, I still need to use this positive and negative signs. So rather, this is just for understanding that it will usually have a negative charge, net negative charge on this one, right? And you already know now that why it will be a negative one. If you have any question, feel free to ask me. But the semiconductor block which you are taking, that is an n-type semiconductor, and then we already have studied that in the pure semiconductor, when we add pentavalent impurities, so these are known as pentavalent impurities. What is penta? Penta is 5. What is valent? It is in the valence shell. So in the valence band, we have 5 electrons, and that is why it is pentavalent. This one, this is trivalent. Understood? Right? So now, simply, what I'm going to do is, I'm going to just use this one. Plus, and here, instead of minus, I'm just going to call it as electrons. So up till here, let me know if there is any doubt. Because if you have any doubts, I cannot continue. I'm giving you 2 minutes. Try to digest it. And ask me questions. Oh, no, chair abu. हमारा कोई जरूर नहीं. बैठो बैठो वांदो नहीं. Yeah, tell me. So up till here it is clear to everyone. Now just think about it. That this positive and negative, we'll try to bring it together. Can anyone now tell me what will happen? So try to bring the blocks together. And then you know that we have studied this electrostatic force. Right? Yes. So now there is two phenomena which will occur. Let me make this one later, because initially, so this is the initial condition. Let us say that we bring it together for the very first time. Right? So we have P-type semiconductor and we have N-type of semiconductor. P-type, as we already have discussed, it is positively charged. So majority of the charge carriers, they are holes. I already explained over here, right? That positive, which means holes, negative, which means electrons, right? So majority charge carriers. So yesterday I gave you an analogy that electrons, we are electrons, and the chairs are holes, right? Chairs can move, chairs cannot move. It's always the electrons which will move. Understand? So now, when we initially bring this P-type and N-type together, now can anyone tell me what might happen considering that holes cannot move? Only the electrons will be able to move. Now, there are two things which we want to keep in mind. First is diffusion. So let us first understand what is diffusion. So it is something like this, that at the start of the class, the number of chairs over here, right? You guys were outside. And at 10, we told that the class will start. So what you'll do, you'll start coming inside. It's like we are bringing the P and the N type semiconductor together, right? So electrons are coming and they will try to do what? You tell me first. Now what will happen? Because I am only interested at the junction. What will happen? Because you are bringing something which is positively charged, you are bringing something which is negatively charged. So I want to know that till what particular time the students will be able to enter in the class and when it should be stopped. So that I want some kind of equilibrium. Otherwise what will happen? If the students will keep on coming and coming, that is not right. I want to put a security guard over there. I need to tell them that, okay, now the class is full. I cannot allow anyone else to enter. So initially, when I'm bringing, so when the class is empty, at 10 o'clock you started to come here, right? And you start to occupy the place that is known as a diffusion. Understood what is happening? Because you are bringing two things together. You will come here, right? You will start taking your places. That is diffusion. Now what I'm doing is I'm putting a security guard at the gate. I want that, okay, no, I don't want any more students to enter the class. Now that is where this electrostatic force will occur, because I still have more students who wants to enter in the class, but I cannot allow them to enter because now there is an equilibrium which should be maintained when the P and N junction are bringing together. So this electrostatic force, which we already have discussed over here, right, that acts as a security guard over here. So when the diffusion is equal to this electrostatic force, we can say that the equilibrium will be achieved. And as a result, what will happen is, now I'm going to draw the actual structure, which will now not allow any more diffusion to take place, right? So just understand one thing, what will happen is, yes.
Can I have any of those contacts?
Yeah, please. Yeah, why not?
Two boys. We need to book your train tickets. So, two boys. Two boys. So, can I have your
Yeah, why not?
Very sorry.
That's fine. So now I have modified this structure now. Can you at least try to make it logically? Just taking this into the mind that there are holes which were chairs, we were the electrons. Initially we started to come in there, diffusion occurred, right? And especially what I'm doing is, consider this as a junction, because this is a boundary, right? So this initially was your P type, right? And this was your N type. And then whatever I have done now is just near the junction or the P-N end, right? So just at the boundary, now I'm keeping something. So there are more electrons on that side. Whatever you guys are there, you are there now. But now I need to understand that I cannot allow more number of electrons to be there, because whosoever can occupy the places have already occupied it. Any more cannot occupy the space anymore, right? And so this positive and negative has got something to do with this trivalent impurities and the pentavalent impurities. So can you tell me that initially, when you're bringing it together, there were holes over here, right? Holes that are made up of, why there were holes? Because you have added a trivalent impurity over there. Trivalent impurity, there is only 3 electrons over here and 1 is hole. So blue is hole. Understand this thing, right? So if there is a hole, can you imagine that the electrons can move from this side and they will occupy. Hope you're understanding this thing. Right. And when that happens, what will happen on this particular side? You tell me now. Because if the negative charge has moved from N type, which is electron, and they have occupied this particular place. So this was initially positively charged, and this was initially negatively charged. Yes or no, near the boundaries. So an electron move from here to this side, occupying the hole. Why do you think that I have drawn this particular sign over here, which is negative and positive? Can you at least try to make it? I'm giving you 5 minutes. I can explain you this thing once again. I mean, at least the question. What is my question to you? That we have p-type. Majority of the charge carriers are holes because it is positive, and positive, which means there are maximum majority charge carriers are holes over there. For N-type, negative, and it is made up of electrons, right? So it is full of electrons over there. And now we are bringing it together. Now you already know that P-type we have formed by adding trivalent impurities. And N-type we have formed using pentavalent impurities. Understood? So we have extra electron that can move. And it can go and occupy this. Because there is no electron here, there is a hole over here. And you already know that positive and negative attract each other. So initially what will happen? Initially this force of attraction will occur. So electrostatic diffusion also occurs because of that itself, right? Yes or no? Right? Now what happens is near the boundary. Can you think about why I have drawn this particular sign which is opposite to the charge of the p-type? Too much? I think you can just think logically. I mean, I don't think there is, you need to understand science over here. I think this is very much a general question. It is all based on the charges itself. Because you need to understand this thing, that this are all the electrons. This was hole. And we have on this side, initially, which was all pentavalent impurities. So an electron was allowed to move freely. So when electron move from here, what will be the net charge on this side? And when this electron move on this particular side, yeah, sure. What will be the charge of this one? So just understand in simple language. Electrons initially were there. Electron is having a negative charge. Agree? When electron moves, what will be left over there? When you move, a chair is there, yes or no, right? And chair is having a positive charge, yes or no? All of you agree with me? Because if a charge is moving, something is still there. Agree? So negative charge is moving, the positive charge will still be there, right? So that is why what I made over here is electron has moved, right? What is left over, so that electron has gone onto the other side, it has occupied this particular place. So because of that, what will happen now on this side? Because this electron has now moved, I am left with a positive charge now, because there is no, why I was calling it negative? Because I had an extra electron over there. But yeah, please. Yeah. No need to take permission. If anybody wants to go outside, go to washroom for water, you're free to do that, right? Don't take permission, it's completely fine. So getting up till here or not? Right? So that is why we have positive on this side and negative on this side. But now just understand one thing. So this electron moved. Now we have 4 valence electrons left. If we have 4 valence electrons left, will that be in a state to, now will there be any mobile charge carriers left? Because this electron has moved on this side. So over here also there are 4. Over here also there are 4. Will there be any mobile charge carriers which will be there anymore? Not near the junction, right? Hope you're understanding this thing. And that is why we call this region as a depletion region. So depletion region is a region which is devoid of any mobile charge carriers. So what were mobile charge carriers? These electrons, and we call it holes. So these two, they can initially move. I mean, although these holes cannot move, but we consider, right? Just hypothetically, we think that they are mobile charge carriers, right? But now, when this electron has already moved on this side, you already know that the pure form of semiconductor, if there are 4 electrons, they'll form a covalent bond. And then there'll be no more hole left over there or no extra electron left over there. Are you guys getting or not? Yes. Right. So with that, we can say that near the junction, now we will be not having any holes over here, which is left, neither any extra electron which is left. Right? And this prevents the current to flow from one to other semiconductor. Hope it is clear to everyone. If not, please let me know. I'm ready to explain this 10 times to you. Because if I cannot explain this to you, I'm a very bad teacher. As Ankur sir was telling yesterday, right? So yes, what do you get? Whatever you have got till now, can anybody try to explain it to me? Whatever you got. So that I know that you guys are getting something out of it. So we had a pure form of semiconductor. We now have p-type, which is the majority charge carriers are holes. For the n-type, the majority charge carriers are electrons. Now we are bringing these holes and electrons together. So when we're bringing it together, what will happen? So just go back to this structure. So when we are bringing it together, what happens is this electron, which is, let us say, I am the electron, I see a chair there. Of course, I'm going to go there, right? So what I'm doing is, I am going and occupying this chair. So near the junction, what will happen, that whatever places were there, they'll all be occupied now. So when it gets occupied, which means that now instead of a hole, there'll be electron on this side, and also one electron has left. So they're both left with 4 valence electrons. And you already know that because if you have another boron over here, right? So what is going to happen? It is going to make the covalent bonds over there. And that is what happens near this junction. And that is why we can say that there will be no mobile charge carriers. No mobile charge carriers is, there is no hole left on this side, neither there are any electrons left on the n-type, which can move freely between each other. Hope you're understanding. And that is only happening near the junction, not inside. Why? Now, this one. So there's positive, positive, negative, negative, and positive, negative. So what will happen is that this electrostatic force and the diffusion, now what it is going to do is, it is going to now prevent any additional charges to come and sit at that particular place, right? So there is a boundary which is getting created, and so p-n junction diode. So diode is like the most fundamental part of the electronics, which is widely used. Even the LEDs, you see the LED lights, right? At LED light, they're also made up of p-n junction itself, right? So the structure is something like this only when you create your LEDs. So basic structure of your LED, which gives you light emitting diodes, right? So this P and N junction, when you're bringing it together, it is also known as a P-N junction diode. And the structure of the diode, or the symbol of the diode is like this. So this side is positive and this side is negative, where this is P and this is N. Understood? Up till here it is clear to everyone? So now, what we'll do is this particular PN junction, it is under equilibrium. We are not giving any external battery to it. But now we will see that what will happen if we connect a battery to this PN junction. So now we will see that what exactly happens to this region, because this region will be known as a depletion region, right? चलो हाँ तो आपने कनेक्ट कर दें ना बच्चे बता ही दिया आप लोगों ने तो बता ही दें ना आपने We'll show you one animation for the PN junction so that you will understand, right? તમારા ગામમાં તો કશું કરવાની જરૂર નહીં એમાંથી જ થઈ જાય ને સીધું આ ખબર નહીં ચાલતું કેમ ખબર જ નહીં થયો નહીં થતો એવો તો HDMI કેબલ લગાવી દઈએ ને એ તો હું સોર્સ કરી દઉં હા ના એ તો સોર્સથી થઈ જશે બરાબર ને એટલે હા કેમ ઓ નો સિગ્નલ આવે yeah please नहीं दादा એવો તો આમાં કદાચ વોટ્સએપ કનેક્ટ આ પેલો વાઈફાઈ કનેક્ટેડ નહીં હોય મને એવું લાગે છે હા ને કનેક્ટેડ જ છે.
હવે આવશે ભાઈ. તમે કન્ટિન્યુ કરો.
હા
તમે કન્ટિન્યુ કરો.
તમે પેલું ટ્રાય કરી જો કરવાનું હે ને. I think there is some problem with the connection. He's fixing it. We'll show you the animation, but before that, let us get back to our structure. So now,
Diode, Part 1. Objectives.
okay, let's see
To
this.
understand the formation of PN junction. To understand the term diffusion current. Most electronic gadgets like laptops, mobile phones and chargers consist of a circuit board. There are several minute components like capacitor,
This is capacitor.
transistor and resistors
Which we are going to study next.
on these boards. One such component is called diode. The diode is a two-terminal semiconductor device which conducts current only in one direction. The device is designed by processing a single crystal of silicon in such a manner that one half portion of it acts as a p-type semiconductor and the other half as an n-type semiconductor. The contact surface of the two is called the junction. The conduction of charges across the junction occurs due to two different coexisting mechanisms. 1. Diffusion of majority charge carriers resulting due to the imbalance in the charge concentration. 2. Drift of minority charge carriers resulting due to the electric field set up by diffusion. Let us try to understand one of these mechanisms, that is, diffusion, which leads to the formation of depletion layer. As p-n junction is just formed, both p and n regions are electrically neutral. The p-type region has holes as majority charge carriers, while the n-type region has electrons as majority charge carriers.
So whether it is p-type or n-type semiconductor, we have both types of charges. Right? For example, in p-type semiconductor, we have holes as a majority charge carrier. It also has electrons, but electrons have minority charge carriers. So number of electrons in p-type device is very small compared to holes. On the other side, n-type, for example, has electrons as a majority charge carriers and holes as a minority charge carrier. Right? Is it clear? Okay. Now when we join them, get p-type and n-type, right? It's basically called diffusion. We take S. So if you look at this side, this is p-type semiconductor. What do we have the majority charge carrier again? As a majority charge carrier, we have holes, right? The same holes are minority charge carrier here. So number of holes on this side is higher compared to this side. True? Yes or no?
Yes.
Electrons, number of electrons in n-type is higher compared to p-type. Because p-type electrons are minority charge. Clear?
Yes.
This thing, let's say we are in a garden and there are a lot of people together. We try to avoid the crowd. right? Means the majority charge carriers are there, people will slightly move away. Same thing will happen when we combine this two. Electrons from N type, where they are majority charge carriers, will try to cross this junction and will go to P type, where they diffuse with the holes. A lot of numbers. Okay? Yes? Sir told you about that J wala example. Let's imagine in that way. Here we have 100 J's, but only 10 students. 100 J, 10 students, right? So majority is chairs and student numbers are very less. Outside of this class, we have only 10 chairs per 100 students. And when you open this door, what happens? Few students from outside will occupy the chair here. From here, some students will go outside and occupy the chair there. Right? So this process is known as diffusion. Diffusion is going to be happening.
Majority charge carriers begin to diffuse from the region of higher concentration to the region of lower concentration. The free electrons in N region leave behind positive immobile ions near the junction and diffuse into P region. On arriving at the P side, they give rise to negative ions near the junction. The holes in the P region appear to diffuse into N region, leaving behind a negative immobile ion. As a result, an electric field E is set up near the junction, directed from the positive charge to the negative charge. Further, diffusion of electrons and holes results in accumulation of the positive ions in the N region and the negative ions in the P region, resulting in an increase in the electric field near the junction. We know that a charge Q in an electric field E experiences a force F equal to QE. The force F acts in the same direction as E if Q is positive and opposite to
This one or that one?
if Q is negative. Let us apply this to the carriers in the field region. The electrons in the N region approaching the junction experience a force EE in a direction opposite to E and are then pushed back into N region. Only the electrons having sufficient kinetic energy to overcome the force EE cross the junction and diffuse into the P region. Similarly, holes in the P region experience a force E, but in the direction of E and are then pushed back into the P region. Only a few energetic holes from P region diffuse into the N region. To summarize,
This process is basically diffusion, right? Just give you a simple example. Yesterday, we had 3 types of materials, right? कौन से थे वो 3 materials? Insulator, conductor. Those 2 are very easy to get understand, right? I mean, insulator, sir gave you the example of this plastic bottle, never conducts. You do whatever you want to do with the plastic bottle, it's never going to conduct, right? Conductor, on the other hand, it always conducts, right? So I'll just give you one example. Let's say this is some wire. So one end is connected to a switch, one end is connected to a bulb. I'll switch on right? The bulb is going to be on. True? Yes? Even if I change this wire now, let's say I change the wire, I change the ends. Now this end is connected to a switch and this end is connected to a bulb. Still it is going to work. So it flows the current in both the direction, from right to left or left to right. True? Yes, insulator never going to pass the current, right, in any direction, right to left, left to right, doesn't matter. Conductor always conducts. You connect them in any way, True. On the other hand, semiconductor is a unidirectional. The diode, especially, you should have one questions here.
Electrically neutral. The p-type region has holes as majority charge carriers, while the n-type region has electrons as majority charge carriers. The majority charge carriers with concentration. The free electrons in n region leave behind region. On arriving at the p sum.
So here the current only flows from p-type to n-type. If I connect diode in the reverse direction, ulta. So this is p-type. This is the basic symbol of the diode, right? We call it p-type. This is n-type. But if I connect it like this, ulta. Here I connect the supply and here I connect the, let's say, LED, for example. This is never going to be turned on. Okay? So it only conducts in one direction.
Forward bias and reverse bias, correct?
Yes. So that's basically refers to a forward bias diode and a reverse bias. Right? Sir will explain.
बंद करो हाँ हाँ पीपीटी में कर शकाय करो So now let us get back to this diagram or the P and N. So what you understood so far from our discussion and from the video? We had initially a P-type and the majority charge carriers over here, they were what? Holes, right? And sir told that there are something which is known as minority charge carriers. So charge carriers are nothing but something which can carry current, right? So what is the basic mechanism which is leading to the conduction in P-type? They are holes, right? And they are majority on this side, while the same for the N-type, if we consider, they are the electrons, which are the majority charge carriers. So what will be the minority charge carriers in the N-type? Minority charge carriers will be holes in your N-type semiconductor, right? So that is why I didn't show the minority charge carriers to start with, to make it simple. And we are considering that mainly it is formed of electrons on the N-type and holes on the P-type. Now when we bring it together, you already have learned about what is diffusion, right? So when we are bringing this together, the electrons will start to move and occupy some spaces in the holes, right? And that is how near the junction, what happens is that now there will be no mobile charge carriers which will be left. Agree? Because what we are considering as mobile, only electrons and holes we are considering is mobile. All of you understand? All of you are with me? So this and this, they are still mobile because this can still occupy electrons. Understood? And this electron can also move on this particular direction as well. So this and this, they are mobile. But in this region, which is at the junction of this P and N type, if there are no any electrons left and no any holes left, will this structure be able to pass the current from one side to another? Tell me, will it allow or not? So it is something like there is a road on one side. Now consider this is a big river, right? And there is another road on onwards. Now currently there is no bridge between these two roads, Will you be able to pass from one side to another side? You will not, right? So currently, that is the condition which is being formed. So there is a depletion region which is like a barrier, which is like a wall over here, right? Which is not allowing any further electrons to move from one side to another side, right? And that is why it prevents any current to flow in this particular state when you are bringing this p-type and n-type semiconductors together. So this condition is known as equilibrium, right? So in equilibrium, because of this barrier, no current conduction can take place. Is it clear to everyone, right? So just consider that there is no bridge at the moment. Now what we are going to do is that now we are going to check that there are two different conditions which we'll be learning. One is known as forward bias, another is known as reverse bias. And how we will understand is by a very simple phenomena we are going to do that. So we have P and N, and just understand in this manner. Consider this is a battery, the same one which goes in our remote controls, right? So we are connecting similar kind of battery over here. Now just think about it, that it is usually, see, there is very important thing you should understand about it. There is a conventional current direction, and then there is something which is actually flowing inside the device. So what I was telling, that what can move? Can holes move? Holes cannot move, right? It is the electrons which actually moves. So the electron flow direction, I'm going to give something like this. So there is one which is electron flow direction, and then which is a current direction. So current direction, if you check in electronics, they usually give the current direction which is opposite to that of the flow of the electrons. So that is why sir told that when you are connecting this PN junction, and if I connect a battery to it, the current direction will be given like this, which is from P to N type. While electrons are moving in which direction? Electrons will move in which direction? It will go from, because there are more number of electrons on this side. So obviously this more number of electrons can go from here to here once we overcome this barrier. Which means, now let us first consider this case where I am connecting the positive of the battery to the P type and negative of the battery to the N type. Understood? Right? So now my main goal is what? Now I want to make a bridge so that the electrons which are on this side, and there are holes on this side, so now that electrons should be able to move. Understand? And how current flows is, current will flow in this direction. Understood? So how current will go? Basically, if you understand in the flow of electrons direction, because this is N type and this is P type. So now, if we understand from this, and let us say that I keep on increasing this voltage. Let us say from 1 volt, then I give 2 volt, 3 volt, 4 volt, something like this. Then what will happen? So there's a negative over here. Electrons are having what charge? Negative or positive? Negative charge. So when negative charge is given and it is connected to the negative, what will happen to the electrons? Electrons, negative, negative, it will attract or repel? It will repel. So if I keep on increasing this charge, don't you think that this negative charge, if I keep on increasing, what should happen to these electrons? What should happen? Okay, let us say that I'm an electron, I'm a negative of the battery, and ma'am, she is an electron. So what I'm going to do is, I'm going to push her. Okay, you need to go, right? If I push her more and more, right, which means that I'm increasing my strength, right? So she will start moving. Same thing is happening over here. This is negative, right? And electrons are also negative. And because negative, negative, they are going to repel each other. And so if I increase the strength of this, more and more number of electrons will experience a force, because of which the electrons will start to move in this direction. All of you agree with me or not? Right? More and more number of electrons will start to move in this direction, because now we are increasing the force, increasing the voltage over here, right? So battery voltage, as we are increasing, because of that electrostatic, now we are giving the force, and negative, negative repel each other, and because of that the electrons will exert, or electrons will experience more force on that, and because of that electron will start to move in the direction, right? And can you now imagine that if I now increase this voltage more and more number of electrons can move from this side to the other side, and which will lead to what? This particular region, which was initially devoid of any mobile charge carriers, now these electrons can overcome this region. So ideally what we are trying to understand over here is, when we do the forward biasing of this particular region, so this depletion region, which I'm calling it as DR, this in forward bias condition, depletion region is going to decrease, which means that now electrons can easily move from one side to another, because now I'm giving a push, and because of that now this depletion region has shortened. Hope you're understanding, right? Opposite to that, what will happen? So electrons, when it goes from here, it will start to move in this direction. So because of the negative force, the electrons will start to move from here, it enters onto the here, and there is a positive one. So positive and negative attracts. Hope you're understanding. So if I'm increasing it, on one side it is pushing the electrons, on the other side this is attracting the electrons. And because of this particular depletion region is going to shrink. So I'm ultimately decreasing the barrier, right? I'm breaking the wall. I want you to go to the next one, or to the outside, right? If I want you to go outside, I need to open the door, yes or no? So how I'm opening the door is, consider in the PN junction, I have this battery. So when I connect the battery in this manner, when positive is connected to the P type and negative is connected to the N type, in that case the electrons will move from the N type to the P type, and again it will enter the battery. So this is how, if I now say, because I originally told you that the conventional current direction is opposite to that of the electron flow direction, because currently electron is flowing in which direction? In this direction. From where to where electrons are going? From N type to P type? Yes or no? Right? So over here, because this is N type and this is P type, electrons are moving from the N to P. But then I am actually showing that the current is flowing in the opposite direction, which means that the conventional current direction is always opposite to that of your electron flow direction. Hope it is clear to everyone, right? So in other words, we say that the electron, this conventional current direction, I am considering my hole direction, hole. Ideally holes cannot move, but then this is opposite to that of the electrons. That is all you need to keep in mind, right? So now you need to tell me what will happen if I reverse the polarity. So instead of positive, what will happen if I connect a negative to the P type and positive to the N type? Can you think and tell me what will happen? You can draw and you can check.
This takes what, a minute, right?
You should think. Because if you understood this clearly, you can easily understand what will happen if I change the polarity of the battery. So the second scenario which I want you to check is, so this is a forward bias one. I want you to check a reverse bias, and in reverse bias, connect it like this. And you think over here now, that over here also you are changing the polarity. So what will happen to the electron flow and what will happen to the holes flow, based on, you already know that positive positive repel, negative negative also repel, and positive negative they will attract. So based on that, now you come up with a theory that what will happen to this depletion region. Will this depletion region increase in size, or will it decrease, or what will happen to it? All of you got the question or not? So when you are doing a forward bias, because of this battery, you are decreasing the depletion region. All of you agree with me or not? You are breaking the barrier. But now when you reverse the polarity, I am asking a question that what will happen to that depletion region? Will it increase further, or will it also decrease? You need to tell me that. So will there be any flow of electrons or not? At least if you tell me that, then it is okay for me. That if you connect the battery in this manner, can electrons pass from this side to this side or not? So can you say that the current, will there be any current flow when you are connecting the battery like this? So you only need to understand that current can only flow if there is a movement of the electrons. That's all. It is X. Keep it very simple. If there is no electron flow, there is no current. Keep it as simple as that. So is there any electron flow like this? Tell me.
No.
No, right? Good. What about others? What do you think? Will there be any current or not? No? I'll ask you why, yeah? You cannot just say no. You cannot just say no. Or you should just rather say, I don't know. Now tell me.
Yes and no is very easy. Right? At least half of us are always true.
Sir, we are still a little confused about
So I want to know that how much you have understood. First you tell me that how much you have understood, so that I can explain further. What you understood from this? Tell me.
Let's again take an example of that river circle. Right? Let's say we have 3 feet river here, 3 feet wide river. We can easily cross it, right? I mean, we are physically fit to cross the.
I can jump and I can cross.
we get it the
Right.
positive when the positive electron pushes in the negative side. We break the barrier and the current.
It crosses, yes.
But
When you did opposite now, they're confused.
yeah.
Yeah, but that is what you need to think, no? That is the challenge that I've given to you. If I'll answer, then what you will think?
So
Huh?
same, for example, for that river, let's say we are gathered here.
Yes.
We don't have any motivation to cross that river. We don't want to cross it. Why? But let's assume that from this side a big truck is coming. It's not going to stop.
Yes.
Now you have motivation,
Yes.
right? So what Sir has told you that when we apply the negative charge here, the negative charge will force electrons to move,
Yes.
right?
Yes. Yes.
Before that electrons were steady, there is no motivation. Now we know that rock is coming, right? It is going to cross us. So we have to cross it. So we jump. Suddenly we get the energy to cross that river. Yes? Same way when we connect this electrons will get repelled. They'll be forced to move from N type to P type. Right?
Yes.
This basically refers to a forward bias condition. Now we know that if electrons move from, let's say this is your right to left, the conventional current will go from left to right. So current will flow in this direction. Now the question is, what happens if we change this force?
So that is the question
So
now.
question is, now we are again standing in this side, and from that side,
The truck is coming.
truck is coming
Other side.
from other side, and in between there is a river. Now we are very sure that it's 3 feet wide river, right? Truck is coming. Okay? Obviously, truck will fall into river, but let's say the force is so high that it might cross a little bit. It might cross the river and come 2-3 feet on the other side. So what we'll do, we'll move away from the river. True? Yes? So same thing. If I just change this charge, just for example,
You can see here.
right? Rather than this, if I make it ulta, positive, negative. The positive charge or positive terminal of this battery will attract the electrons, because this is positive and this is negative. Have you seen the magnet, north and south, which attracts the opposite and attracts the north with south? They'll get connected, they'll be attracted. Yes, same. Positive charge will attract the electrons. So electrons will go away from the river. So this junction will be wider. Now electrons are not crossing the junction and going from N type to P type. उल्टा हो रहा है. उल्टा क्या हो रहा है? Electrons are moving away, because they know that from other side there will be a truck coming. It might cross, right? So to become safe, we'll go here. We'll even go away. Same idea. So initially the junction width was like this, only narrow, but now it got wider. Good wide. There is no again charge carriers going from one side to another. So there is no flow of current, because junctions are not getting crossed. So there is no current. So as I told you, in semiconductor, current flows in only one direction. I change the ends, I change the force, I change the voltage connection. Now there will not be any current. And this particular condition is now known as reverse bias. It's very simple. Yes, reverse bias. Right? And now the diode won't comes. Okay?
Yes, sir.
So to make diode in forward bias, what is the condition? Condition is that charge should cross the junction. The voltage we apply supposed to be in a manner in which the majority charge carrier crosses the junction. It should have motivation to cross that. Then and then the current will flow. Okay? So keep it. So we'll see if this is a diode. Okay?
Yes, sir.
This is, I have to sit to write on this, right? Otherwise it looks very weird. Pn. In P type, what are the majority charge carriers? Volts. Right? Volts are positively charged. Now imagine I would like to force them to move towards this. Should I apply the negative charge here or positive charge? Negative or positive? Because negative will attract, positive will repel. Positive will force them to go on the other side. So should I apply the positive or negative? and when I connect with the positive end of the battery. This will cross the junction. Yes, true?
Yes.
On the other end, we have N-type semiconductor where we have negative charged electrons. I want electrons to go in this direction. Because ultimately I want the current. For that I want my majority charge carriers to cross the junction. True? So what kind of charge I'll apply here or battery? Negative. Because negative will repel that. True?
Yes.
Now there is a charge moving across the junction and you'll get the current. Right? Have you seen this remote everywhere?
Yes.
Whenever you press the key, there is some small light is going on.
Yes.
We know that. Yes? That is diode, right? It's a diode. This element. It's a special purpose diode which emits the light. It is known as LED. Have you heard word LED? Yes. It's a light emitting diode. Full form is light. It's a semiconductor device. LED. Right, so you see the different colors of LEDs, right? All of them are semiconductor devices. And when we connect that LED in forward bias, it emits the light because current is flowing now. And when we connect it into a reverse bias, it's not going to emit any light. Now, just you think like that. When I press any key, this particular diode will be in forward bias and it emits light. That's the thing. Yes? Any questions?
So we'll ask questions then.
For you, it's very simple. It's very hard to make us understand. You see, you're working really hard.
Try to make, otherwise there is no.
See, because if you don't understand PN junction, you cannot get into semiconductor. This is like,
This is the smallest basic component.
you need to know this. If you don't understand PN junction, you cannot get into semiconductors. It's like the basic block.
Have you studied maths? Any maths? 10th standard? 10th you had maths? Then, right? You know what is Boolean algebra? Boolean? Yes, you know Boolean algebra, right?
Yes.
Boolean algebra is a digital circuit, nothing else. It's a digital circuit. Right? You have heard digital and analog?
Yes.
Analog and digital, yes? Most of the devices are now digital. Why?
No?
Why? We'll discuss digital and analog a little bit to make it understand, right? Why we have digital devices nowadays. Okay, so we'll wait for the T. Yes, because we need T, right?
Yes.
So,
You only
But at least you get something, right? Good. If you need some more clarification, feel free to ask so that we can go to the next topic. But before we go to the next topic, it is better that you understand this thing. So let me know.
we need to understand this diagram.
Okay. From the beginning? Yeah, sure. That's okay. I mean, I don't mind. I can explain you 10 times. Right? But it is better that you understand, right? So let us start once again. Currently, I will not give any kind of biasing, or we can say that we will not attach any battery to it, right? So when we have this with us, what we studied so far, that initially it will all be filled holes on the p-type, which are the majority charge carriers, electrons on the n-type, which are the majority charge carriers. Now when we are bringing this p and n-type together, what is happening? What was the term that we learned? There was something which was starting from D, which was what? Diffusion. So what do you think will happen because of the diffusion? It is the movement of what? Movement of the electrons, right? So when we are bringing this p and n type together, there will be diffusion, which means that electrons will start to move into the p type, right? Now when that is happening, we need to understand that we had on the n side we have pentavalent impurities, right? So we had 5 valence electrons on the n side and we had 3 valence electrons on the p side. So there was a hole over here, right? So initially when the diffusion occurs, because electron is now moving, so what will electron try to do? Electron will move from here and it will go and occupy this hole. Understood? And this process will keep on going until an equilibrium has reached. So the diffusion took place, right? And now because enough charges, so what it will do is when the electron moves from here, it will left with net positive charge over here, because electron is negatively charged. When electron moves, it will left with what charge? Tell me. See, electron is negatively charged. If electron moves, what will be left over there? Positive charge will be left over there, right? So when electron is moving from the n type to the p type, a net positive charge will be left over here. Understood? And because that electron is entering into the p type, so what will be the charge on this side now? It will be negative, because the electron is coming from n type and it is going to the p type. So now over here in this region there will be net negative charge which will be there, right? So now that is the main reason that we show it like this, that after the diffusion takes place, right, rest all will be still holes and electrons only. Understood? Right? So now this one, because we told that electrons and the holes are the mobile charge carriers which can move. But now this region which is formed at the center, that is known as a depletion region. And depletion means what? It is deplete of the mobile charge carriers. If it is depleted of the mobile charge carriers, which means there is no holes on this side left, there is no electrons left over here. So when there is no holes and no electrons, will there be any movement? Will there be any movement? I'm not keeping, there are no mobile charge carriers in that region, right? And that is why it is known as a depletion region, right? Which act as a wall, which will not allow any further movement of the electron from one side to the other side. Do you understand, right? So this happens in the equilibrium condition, right? So a depletion region has formed when we are bringing the p and n type regions together for the very first time, right? So this wall is there which is preventing any further movement of the charge carriers in this p and junction, right? So this is known as a junction. So on its own it looks like this. That's it. Understood?
Yes.
Now in order to make this work now, what we should do, that we can either connect this PN junction like this, which means that when I'm connecting the positive of the battery to the P type and negative of the battery to the N type, or in the second case, I can connect the negative of the battery to the P type and positive of the battery to the E type. So these two conditions now we are checking. So initially we were not connecting anything. We just wanted to understand that what happens when we bring it together. So we understood that a depletion region is created in between, which is not allowing any charge to move from one side to another. It is under equilibrium condition. Understood?
Yes, sir.
Right? Now we want to break that equilibrium condition. If we want, now we want that electrons should move from one place to another. So then what should we do? So we need to push the electrons on one side, yes or no? And from the other side, if somebody is attracting as well, then it will be very good for us, right? It will make an easy path for that particular charges to move across that PN junction, right? So now, just understand over here, negative of the battery is connected to the N type, right? And positive is connected to the P type. So just understand in a very simple term, that negative will repel, which means that the electrons will be forced in this direction. And because this is positive, so positive is also going to attract more and more number of electrons. So from one side, the electrons is getting a push, and the other side, somebody is attracting more and more number of electrons. And as a result, we can say that the electrons will start moving in this direction. You understand?
Yes, sir.
Right?
Yes.
So this is the direction of the electrons, and that is why I have shown like this, that electron direction is like this, and the conventional current direction will be exactly opposite to it, so the arrow is on the opposite side. Understood? So if you look in general, then they will show the conventional current direction. They will never show you the electron flow direction. But now you understand that whatever is the conventional current direction, the electron flow direction will be in the same direction or the opposite? It will be opposite. Yes or no? If the conventional current direction is like this, the electron flow direction will be in the opposite direction. You need to understand this thing, right? So every time they will show you this only. They will never show you the electron direction, right? So the current flow direction will be in this direction, and electron flow direction is in the opposite side. So current is flowing in the clockwise, electron is moving in the anti-clockwise direction. Is it clear? So while doing this, what we understood, that we actually made the depletion region, or we overcome the barrier, right? Because this was a depletion region which was preventing any charges to move from one side to another side. But because of this forward bias, now we have decreased that barrier, and that the charge can move from one side to the another side, right? But now let us look at the opposite scenario, where we are connecting the positive to the E and negative to the P side. So what will happen? Tell me. If positive is connected to the negative, it will attract. Yes or no?
Yes.
So don't you think that more and more number of electrons will actually move in this direction? Understood?
Yes.
Right? So more and more number of electrons are moving in this direction. Don't you think that the depletion region, which was initially like this, it will further extend? Hope you're getting.
Yes.
Right. So that is why we are understanding that when we go for forward bias, we are actually shrinking this, or we can say that the depletion region will not be there. We overcome the depletion region. We overcome the barrier. But in that one, in the reverse bias condition, the depletion region has increased now, and so nothing can flow. Understand? Is it clear? Forward bias and reverse bias of the PN junction.
Yes.
So now sir is going to show you one practical. પેલું દેખાડો ને કે નહીં દેખાડો? નહીં દેખાડો ને? નહીં થતું ને? પહેલામાં જોઈજો ટિંકર કાર્ડમાં થશે. ટિંકર કાર્ડ ઓનલાઈન જ છે. તો ટિંકર કાર્ડમાં થાય ને તો આપણે એ લોકોને બતાડીએ. Fine. So with this, now we are going to move to a semiconductor device which we actually use, and which is a metal oxide semiconductor. Right? So we already have understood what is insulator. What is insulator? Let us quickly tell me. What is insulator? Something which can conduct or not? It cannot conduct anything. Right? So that is insulator. So in our case, that will be oxide now. Oxide, just understand one thing. You can write down. I'm giving you some terminologies. So insulator, we'll be using oxide as an insulator now, right? There is something which is metal. What is metal? It can carry, it is able to conduct electricity or not? Yes. Very, very nicely it can conduct, right? So first layer that we are going to use, that is metal itself. So consider it as a metal, right? So we have first, which is metal. Second, which is oxide layer. Oxide is an insulator. And the third, what we have studied, that is a semiconductor. So metal oxide semiconductor is the thing that we are going to understand first now. So as we understood what happens when you bring PN junction, now we are going to understand what will happen when we bring this metal oxide and semiconductor together. Hope you're understanding now, right? So let us do that. So up till now, do you still have any questions? Anyone? Clear, right? Okay. So if I tell you to draw the energy band diagram, will you be able to do that? What we studied yesterday? No, you can, you should. Because that is what we studied yesterday, yes or no? That valence band and conduction band. So just at least draw the distance between the conduction band and valence band for metal oxide is an insulator and the semiconductor. So can you all draw? Yes. बंद कर दो टीवी हमारा मालूम टिंकर कैड में था क्या नहीं था वाईफाई So in the metal, we discussed yesterday, the conduction band and valence band is almost overlapping, right? And because it is almost overlapping, the electrons can easily move from valence band to the conduction band, and they can freely flow, and then the conduction of the electricity can happen. Clear?
Yes.
That is for the metal. For insulator, like plastic, your paper, why there is no conduction of current over there? What is the reason? Look at the difference between the valence band and the conduction band. It is very high. Yes or no?
Yes.
All the charge carriers are over here. Just think about it. So what are charge carriers? How do you define charge carriers? In your P and N type, we discussed about the charge carriers. Which were the charge carriers? Tell me. Electrons and holes. They are our charge carriers. Understood? So just understand one thing, that all the charge carriers are over here. And there is no more space where it can move, right? They're tightly packed. It can only be in a state to flow when it gets some free space. And where is the free space? In the conduction band. But then just look at the distance between the valence band and the conduction band. It is very high. So what happens is that the charges are not able to move from the valence band to the conduction band in case of the insulators or the oxide in our case, right? So oxide layer acts as an insulator. It will not allow any current to pass through that particular device. Understood? Right? See, if there is a supply, right? What will happen if I use a metal pin? I'm holding it, and if I put it inside, I'll get a shock. But if I have a plastic, and if I put it inside, will something happen? Nothing will happen, right? So same thing. First is the metal, right? Because the valence band and conduction band, they are almost overlapping, right? The current from here can easily pass to my body. But when I'm using plastic, it will not allow any charges to pass from one side to another side. So this is acting as an oxide over here for our metal oxide case, right? The third is the semiconductor. Now semiconductor, what will happen if in the pure form, if I'm using a semiconductor, nothing is going to happen to me. But instead of that, if now I use a semiconductor block which is extrinsic, so let us say P type or N type semiconductors, right? So why semiconductor are known as a wonder materials are because we can change the property. So you can think about it that semiconductor, when it is in its pure form, it acts like an insulator. But when we add the impurities, it will act as a metal. That property you cannot change for an insulator and metal. Can you do that? Can we change the properties? Can you change? We cannot change the properties of a metal and the insulator. I cannot change the property of this pen and make it a metal. Can I do that? It is not possible for me, right? But semiconductor is the material which I can use it as an insulator and as a metal, and that is why this is known as a wonder material. By adding the impurities to it, I can make this material to conduct when I want. You understand, right? That is why semiconductors are most preferred materials nowadays for making this kind of integrated circuits. You understand, right? So now what we are going to understand over here is when we bring this metal oxide and semiconductor together, what will happen, right? So similar thing will you need to keep in mind that when we bring this P and N junction together, the diffusion was occurring. Similarly, when you bring this metal oxide and semiconductor together, because just think about it, that metal is filled with lots of mobile charge carriers. Yes or no? Right? There are a lot of mobile charge carriers over there. While in insulator, there's nothing. I mean, it won't allow anything to pass through. So just think about this. These three things. So your pencil acts as a metal. The remote control acts as an oxide layer. and this pen acts as a semiconductor. So the structure looks something like this, which is metal, oxide and semiconductor. So just imagine one thing, that what will happen if I start giving voltage from the top. Because in the PN junction diode, what we were doing was that we were connecting one of the terminals to the positive, another terminal to the negative. So similarly, I want to check that what will happen to this structure if I connect it to the battery. Hope you're understanding, right? That what we are going to check. And this metal oxide and semiconductor is the basic block to understand your N-type semiconductor and the P-type semiconductors, right? I mean, N-channel MOSFET and P-channel MOSFET. So this metal oxide semiconductor we will only understand if you understand your MOS structure clearly. And that is what we are going to learn now. Understood? So we are going to make a stack like this. And when we make a stack like this, we want to now see that how this device will start to conduct electricity. So is the scenario clear to everyone? Right? So now there is no P and N. Because now what we are going to do, just check over here that what I have mentioned next to semiconductor. What I have mentioned, it is which type of semiconductor? P-type semiconductor. In P-type semiconductor, what are the majority charge carriers? Majority charge carriers are holes. And what about the minority charge carriers? Electrons are the minority charge carriers, right? So currently just understand this thing, that the top layer is a metal layer. In between, why you are putting an oxide layer? Because if you are not putting an oxide layer in between the metal and the semiconductor, then there are chances that there is a short in between the metal and the semiconductor, because you can make the semiconductor as a conductor. Yes or no? And if there is no oxide layer in between, there can be a short circuit between these two things. So you don't want that. And that is why this oxide layer is preventing any charge to flow from this to this. It will keep confined the charges to these layers only. No charges will be allowed to move from one layer to another layer in this case. Clear up till now the structure? So now, થઈ ગયું? ટિંકર કાર્ડમાં બતાવો થાય છે ને મસ્ત. આમાં ડાયોડ નહીં બતાવતો, નહીં ડાયોડ બતાવો પડતો, પણ ડાયોડ નહીં આવતો. ડાયોડ તો પણ આવી રીતે કરીશું તો એ લોકોને નહીં ખબર પડે ને. સ્વિચ મૂકી દો ને, સ્વિચ મૂકી દો, એટલે સ્વિચને ડાયોડની રીતે બતાવી દઈએ આપણે કે સ્વિચ ઓન ને સ્વિચ ઓફ. તો જ્યારે ડાયોડને ઓન
કનેક્શન ઉલટું કરશે ને
એટલે એવું નહીં, હું શું કહું છું કે રેઝિસ્ટરની જગ્યા પર સ્વિચ મૂકી દો અને સ્વિચને જો ડાયોડ કરી દો કે ડાયોડ જ્યારે ફોરવર્ડ બાયસ હોય ને તો એ સ્વિચ ઓન, અને ડાયોડ જ્યારે રિવર્સ બાયસ હશે ને તો એ સ્વિચ ઓફ. હે પહેલે એ તો આપણે ખાલી ઓન કરીએ છીએ એટલે આપણે બતાવીએ છીએ કે કરંટ ફ્લો થયો, નહીં તો કરંટ ફ્લો નહીં. એવી રીતે બતાવો, પણ મારે એવી રીતે બતાવવું છે. એટલે અચ્છા, એટલે એને જ તમે બતાવો છો. મારે એવું બતાવવું છે કે જ્યારે આપણે અહીંયા જે ડાયોડ, અહીંયા જ પીએન જંક્શન ડાયોડ છે, તો જ્યારે આ ઓન થશે તો જ કરંટ પાસ થશે ને એલઈડી ક્લો થશે. ખબર પડે ને? એવી રીતે અહીંયા આગળ હા, ને સ્વિચ જ મૂકી દો તો બી ચાલશે. અહીંથી નહીં, પુશ બટન એ સ્વિચ એક હતી, સ્લાઇડ સ્વિચ છે ને, સ્લાઇડ સ્વિચ મૂકી દો ચાલશે. So all of you can write down the name of this software. Huh? You can all try. It is excellent software to learn the basics of electronics. You can connect the circuits. Whatever we have studied, this is online free tool. It is Tinkercad. Like the best one to start learning the basic of the electronics or the physics. Most of the components are over there in Tinkercad. Even my son, who's currently in 8th standard, he's using it. He is excellent at that. And he is now using Arduino board and Raspberry Pi over there, right? Which are like the some high functionality boards, not just the components, right? So if he can do that, I'm pretty sure you guys will very well be able to use this software. It is very easy. So sir will demonstrate you one scenario. So first of all, you understand the scenario. So sir will explain now. Circuit बना हुआ नहीं? क्या चाल से?
This is
क्या बना है तो वही है.
you'll understand, right? I mean, P-type
लो,
should be
sir.
As discussed, P-type semiconductor should get connected to a positive terminal. Yes?
Yes.
And N-type should get connected to a negative terminal of the battery, right? So this is basically a cathode of the LED. This is LED, right?
Yes.
LED is light emitting diode. It's a simple diode, right? This is just a slide switch to tell you that when we switch it on, it will get connected, otherwise it is disconnected, right? So if you want, I can, time being, let's remove that. We don't want, let's make it very simple. So anode, if I click here, it shows me the anode, right? Anode is basically a P-type semiconductor. The name is anode. We call it anode, right? And N-type is basically a cathode. So N-type is connected to a negative terminal. You can see here, it's a negative. And positive is connected to P-type. Is it clear? It's very simple. So diode will be in forward bias. Yes? Let me explain. This is our PN junction. Yes? This is known as anode. This is cathode. Done? What we do now, we connect it to positive terminal of the battery. What do we have here is a majority charge carriers, holes. So positive will repel, right? So we'll force these holes to cross this junction and go to the other side. We'll make them cross the river forcefully by applying the external force, like voltage. This is a negative. Negative is connected to a electrons. Again, they'll repel. Electrons will go from N-type to P-type. So majority charge carriers are crossing the junctions. Yes?
Yes.
And then there will be a flow of current. Agar current flow hoga, then the LED will emit the light. Right? So let's see that here. So now this is basically a anode. So this is P-type, which is connected to a positive terminal. This is battery, by the way, 9-volt battery. Okay? This is negative and it is connected to a cathode. So the moment I run this, what happened? This is not emitting the light, by the way. It says that it is damaged. Why? Why it is damaged? It says it's emitting the light, but eventually it got damaged. Right? Why? Let's make a little change to it, right? Just simple change. Okay, now it's just turned on. That's it. Simple. Yes? It got turned on. That means the diode is in forward bias, and it says that now it is okay. It is not going to get damaged. Right? So why earlier case, what was missing? Resistor. And what does resistor do? Resistor limits the current. Right? Resistor limits the current. Right? So for example, any equipment, electronic equipment has current rating. It can consume maximum this amount of current. So when you don't put a resistor, it can take the any number of, supply, jo bhi, whatever the current it can supply will take it, right? And eventually it will get damaged. If you can eat only 2 breads, you should not eat 4 or 5. Otherwise, right, you'll be in trouble.
The
Same.
simple example is this fan. So usually in the fan, what you are doing when you change the regulator? See, currently if it is 1, if I increase the speed, why it goes faster?
So
is happening to it?
what I am doing is I am reducing the resistor. If I am reducing the resistor, it will able to take more current. More current will result in more revolutions. Right? So when I slow down it, actually I am increasing the resistance. So resistance will resist the current. It won't allow to pass. Okay?
Yes, sir.
But the idea here is, now we would like to see what happens if we do the reverse connection. Let's say I change this. Now the negative is connected to a P-type semiconductor, the ulta. And then the positive is connected to a cathode. Let's see whether the LED should turn on. No, because what we have done, we have changed the directions, battery directions. Actually, jo river, now there is no motivation to cross it, right? Because stroke is coming from other side. So in fact, will go away. Yes?
Yes.
So there will not be any flow of current, and you can see that the LED is not turning on. Yes?
Yes.
Is it clear?
Yes, sir.
So this is a very good tool. You can use it, right, to understand the electronic components.
Yes.
To work with the actual components, you have to be very careful, right? Because we generally used to tell this to our student, like current and gold are same. Have you seen gold? But we believe there is a gold. True? Current is same. If there is any live wire, right? We said there is a current going in this wire. We cannot see that current. Okay, current is going. No. But when you touch it, you feel it, right? So you have to be very careful. So this is best way to start with, right?
Here? So the simple analogy over here, what started, we have a battery, we are connecting a PN junction diode, and then we have LED over here, right? Simple. So what you should understand is, in which particular condition the LED will glow. So now, based on how we are connecting the diode, whether it is in the reverse bias condition or in the forward bias condition. So currently, what do you think? It is connected in the forward bias condition or reverse bias condition? It is connected in the forward bias condition, right?
How will you identify that?
How will you identify?
આ લોકોને પેલો ડાયોડ એ બતાડો ને એક્ચ્યુઅલ ડાયોડ.
No, how will you identify? It's very simple. Positive terminal of the battery should get connected to P type and negative should get connected to N type. Then the majority charge carriers will be repelled and it will be in forward bias. You can see here the positive terminal is connected to P type. Negative terminal is connected to N type. So they are in forward bias. Let's have some examples. You have to identify whether diode is in forward bias or reverse bias. That's it. So what you have to do? You have to point out the positive terminal of the battery and you just need to check where it is connected. Is it connected to a N-type semiconductor or P-type? If it is connected to P-type, the diode is in forward bias. If it is connected to N-type, then the diode is in reverse bias. Simple. Okay? So for example, this is diode, this is P-type, this is N-type. If I connect battery like this, positive, negative, forward bias, reverse bias, forward bias, right? Because positive terminal is connected to P-type, negative is connected to N. The diode is in forward bias. So the current will flow. Current will flow. Simple.
So this current direction is which one? Electron flow direction or the conventional current direction? Just this one, the one which is shown with this red inside. That direction is which direction? Conventional current flow or electron flow direction? Tell me.
Conventional current.
It will be a conventional. Why? Because the negative is connected to N type over here. So electron will move in which direction? Electron will move in which direction? Tell me. Where were electrons? Electrons were there in the N type. All of you agree or not? Right? P type is having majority charge carriers which are holes. N type, the majority charge carriers are electrons. So when I am pushing the electrons, because I am connecting negative to N type, the electrons will be pushed from this side to this direction. So electron flow direction is in which direction? It will be opposite to that of the direction which is shown over here. So that will be in anti-clockwise direction, while the conventional current is in the clockwise direction. Hope you're understanding this thing, right?
Okay.
So keep that electron and hole picture in your mind, because right from the symbol it will make the things difficult for you. So just keep one thing in mind, that where were more number of electrons and where were more number of holes. And now you are connecting the battery to it. So based on the electrostatic, we learned positive, 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 negative. So like charges will repel, while opposite charges will attract each other. Keep that thing in mind. And based on that, you should be able to tell the direction of the current and whether it is forward bias or reverse bias. Now sir will give more example and you'll be able to answer.
Chalo. So this is
હમણાં કરશો નહીં એવું કરો પણ ના 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 આ નહોતું કરવાનું, આ એમ નહીં જોડે કરાવડાવવાનું તમે.
okay.
Okay. So what will be your approach? How to solve it? What should you do? The first and the foremost thing is the sign convention. What you should do is, where should you write positive and where should you write negative? Tell me. So always in the battery, whenever we do that, the longer one, that is positive. Shorter one is negative. So first of all do that. Where will be positive, where will be negative? My left or your? So this one will be positive or negative? Positive. This one will be Negative. For the P and N, see this triangle, right? The line that is N, which is negative. And on this side, the triangle N, that is P. Now, after doing this, it will be very easier for you to tell whether it is reverse bias or forward bias. So that should be your habit of identifying the things. So do that now. Shouldn't take you too long, huh?
Very simple.
It's very simple. Now you should be able to answer. Come on, there is reverse bias or forward bias? Reverse bias. All of you should have justification for that. I am going to ask any of you randomly. Don't be scared. Huh? But at least you should have justification, right? I mean, that is how we know that you are getting something.
For forward bias, positive terminal lead to connected to P type and negative terminal must get connected to N type.
So just understand
Reverse
this.
bias, it is ulta. Positive will get connected to N type and negative will get connected to P. Simple.
So you only need to keep this in mind.
Positive is forward bias,
Very easy for you.
positive, negative, positive is reverse bias. Right? So you can see here negative is connected to positive. So it is reverse bias. Positive is connected to negative. It's reverse bias. But if I change the battery direction, the positive will now get to positive. Negative will get connected to negative. It is forward bias. Right?
So you should understand this too. That is why I have mentioned over here that when the positive is connected to the P type, as I said, and the negative is connected to the N type, we can say that the PN junction can now conduct a current, and that is why it is considered as a closed switch. So the current can move, yes or no? While when you're connecting it in the reverse bias condition, the switch is open. There will be no current flow through it. Hope you're understanding this thing. This is the simplest thing to make your concepts clear. If you understand this, that's all. Whatever circuit will be given to you, you'll be able to solve it. You only need to know when the switch will be closed and when the switch will be open, because diode acts as a switch. Simple. PN junction diode acts as a switch only. It can be either turned on or turned off based on how you're biasing it. Simple. Right? Sir, any other example you have?
Yes, this one. We'll try some different combinations of diode and batteries. I mean, this example is again a very good way of understanding the semiconductor. Again, insulator never conducts. So switch is always open. Switch for insulator, it is always open, right? Because it never conducts. Conductor always conducts. So switch is closed. But semiconductor, by just changing the supply voltage, you either make it close or open. It's a programmable thing, right? You get something in between insulator and conductor. If it is fixed, you cannot use it for the computation.
The lunch will be ready from 12:45.
12. Okay. After 5 minutes.
Yeah.
Okay.
Okay. Yes. We'll only break for the lunch once we clear this. It takes one
Carry on
minute, we'll
the
continue
topic,
till
you
one.
can finish it.
There is
I think it's
external
almost done up till now.
course which will
Yeah,
make
yeah.
you
Break it for
more
lunch.
time.
That's
Right? Come on.
so quickly. This is forward bias or reverse bias? Forward bias. So what should be your? Did
How
you
do you know?
put the positive, negative, P and
Okay, and just answer me. What is this? Positive. Chalo, now I just say
It's forward.
see. Very easy. Right? Why?
See, becoming
This is
good.
again- This is positive. This is P10 forward bias. True.
Now you know to Dorvano.
This is
He is helping you. He wants you to have lunch.
okay. Forward bias. Very good. Okay, now I'll make two diodes in one circuit. You have to identify, right? Two diodes in one circuit.
Forward.
This is, let's call it D1 and D2. D1 is in forward bias, reverse bias.
Forward.
Why?
Positive.
Because it's
Positive.
positive is connected to
Positive.
positive. Very good. D2.
D2 is connected in forward bias or reverse bias? What do you think? Huh? So now,
Why reverse? No, first tell me why reverse. How many of you say that this is, okay, let's differentiate the, right? How many of you say that D2 is in reverse bias? Come on.
come on, lunch is ready, huh? Lunch is getting cold.
It is in reverse bias, right? It is in reverse bias. How many of you say it is in reverse bias? Tell you it is in reverse bias.
Now he doesn't want you to have lunch, huh?
Okay, how many of you say D2 is in reverse bias? Again. That means all of you are agree that the D2 is in forward bias.
So,
yes or no?
so now the best method. Now I'll help you a little bit. Huh? I think he doesn't want you to have lunch, but I am now a bit concerned. So the first one, diode 1, let us say you identify that it is in forward bias, right? Can we replace it with the switch? You just close it.
Okay, so yes. Once the diode is in forward bias, what you can do is you can remove the diode. For example, I remove it, and what I'll do is I'll connect the switch.
Now you tell me.
Now you tell me whether
State of
D2
D2.
is in forward bias or reverse bias.
It's in forward bias.
Yes, you're right.
Say loud. Ah, now you know. Now you are excellent at semiconductor technology.
It is in forward bias, right? It is in forward bias.
Hope you're understanding, right?
Yes.
Good.
Two more examples.
Two more, huh? So now you can use this, huh? Switch. Replace it with the switch. And it will be easier for you.
No, it looks very difficult, but it's
Very easy, very easy.
very.
એ લોકો પેલું સિરીઝને પેરેલલ થોડું કહેવાનું હતું પહેલામાં
Sorry? Okay.
પેલી સર્કિટ
Yes.
પેલી સર્કિટ રાખો તો સિરીઝને પેરેલલ બતાવે બાજુમાં
D1. Right?
પેલી પહેલા વાળી બી છે ને રાખો
ઇરેઝ કર
એટલે બાજુમાં બનાવી દો ને
Do you want this forward?
તો સિરીઝ અને પેરેલલ
પછી પાછી બનાવી
તો સિરીઝને પેરેલલ છે ને પેરેલલમાં બતાવી શકશો તમે
Ah,
D1 is forward.
D1 is forward bias, and what about D2?
વોટ અબાઉટ D2?
Reverse bias.
Yes.
Okay, how many of you said D1, D2 is reverse bias? Raise your hand. Raise your hand, huh? See, those who raise your hand only will be able to go for lunch.
Yes.
Rest needs to understand first.
You have to answer, it's compulsory. You have lunch, you have to answer.
Chalo, D1 forward bias. Raise your hand. How many? D1 forward bias. Raise your hand. How many? Everybody,
Let's go with the majority. D1 is in forward.
D1.
bias. We don't have any confusion in that. D1 is in forward bias.
What about D2 now?
What about D2?
Huh? D2.
D2.
You need to check whether there is any current flow or not. So current will enter from the positive. It should go to the negative. Over here, it should enter from here to here. So is there any flow like this in the loops? There is one loop.
Don't get confused with yourself. P, P, N, N. It's enough.
Just put that.
Right?
Huh?
Just put all the.
D2 is forward. You are staying whole day over here now. Not going anywhere. Not even high tea. At 3 o'clock. No. No lunch, no high tea.
Just put that P positive, negative sign, P, N, and you like that, correct? P is forward bias, P, N is reverse bias, or N, P is reverse bias. Okay? Chalo. D1, forward bias, we all agree. D2, what is this? This one?
N or P?
N or P?
P. You look here.
N. Is N. Okay, so this is N. And this is P. I'll note it down for you.
બે જુદી જુદી હોય ને તો બનાવી દો ઉપર એક લૂપ બનાવી દો અને નીચે બીજો આનો D2
N and P. Done? What is this? Plus positive. Now positive is connected to negative. P N. Forward bias, reverse bias. We're right? This is a reverse bias.
neutral forward. I remember that.
So D1 is in forward bias, but D2 is in reverse bias. Yes. So D1 will conduct, D2 won't conduct. D2 will work as an insulator, D1 will work as a conductor.
So one thing you need to understand over here is when it is connected like this. Sir, पहले एक series वाली draw करता हूँ बाजू में. I want you to understand one concept. Why you got confused, I can understand. But this will make it very easier. Just
First, let's get the answer for this from them. D1 and D2.
let's do that. Chalo, D1 is in forward bias or reverse bias? Replace it with a switch.
D1 you will easily get, right? We all have the problem with
D2.
Let's rename that.
He always make that D2 difficult.
Let's call
Make
it
D1 difficult.
This is D2 and this is D1. D1 will easily get, D2 we have the problem, right? So now D2 is in? Very good. What about D1?
So replace it with the switch. That is the first thing. Now you tell me the state of D1. Reverse bias. Perfect? So this kind of connection is known as a series connection. They all are connected in series. Do you see the difference in between the connection of the diodes in here and in here? This kind of connection is known as a parallel connection. This is series connection. So in series connection, if one of the diode is not working, which means the switch is open, there is no further path for the current to flow. But in this case, let us
Please
say,
remember this, I'll make one question out of it and I'll ask you again after.
Yeah.
Yes. Sir, please continue.
so next is we have parallel connection. So now understand this thing, that your D1 P is connected to positive and N is connected to negative. So our D1 is forward bias. Yes or no? Yes. So the current can flow in this path. All of you agree with me? Right? Next thing. So let us say that now you have closed the switch because this is forward bias. Right? Even if it is in reverse bias condition and the switch is open, it still is not going to make any difference to the next one. Right? So that is what we are going to understand. Now this D2, the N is connected to the positive and the P is connected to the negative. So this particular diode is reverse bias or forward bias? Tell me. This is reverse bias, right? So the current will not flow in this particular path. but it will still flow in this path. This will not be the case over here. If any of the diode is not in forward bias condition, the circuit is not closed, and then there will be no current flow. So you need to understand one thing, that for current to flow, the circuit should always be closed, which means that there should be connection from this positive all the way to the negative. If there is a break in between, we can say that there is no current flow. Understood? So that is not a problem for the parallel case, because in parallel it still have another path from which it can still reach the negative. Yes or no? Even though it cannot reach through this path which was open, but it can still go from this path and it can reach the negative. Hope it is clear to everyone, right? So series connection and parallel connection, that is the difference. Understood?
Yes, sir.
Sir,
That is in reverse bias, it is open. Forward bias, it is closed. Right? Let's quickly just replace those diodes with the switches. That will help you understand one important point, right? For example, this diode D2, is it in forward bias, reverse bias?
Forward bias.
So yeah, here we'll just put a
Switch.
switch which is
Close switch or open switch? Close switch, right? Close
which is
switch.
in forward bias. Forward bias is closed. So it's a conductor. This
What about
D1
D1?
is in reverse.
Reverse bias. So open switch or close switch? Open switch, right? So will there be any flow of current in this particular loop or not? There will be no flow of current.
Right? Because one of the switch is open. Though one switch is closed, but still one switch is open, it is not going to. Imagine that this fan is controlled by a two switch. If both switches are on, then and then the fan will on. But if one of the switches is off, the fan is not going to turn on. It's very simple, right? But on the other hand, this circuit, this diode is in
Forward bias.
bias.
So close switch.
Yes. This diode.
Reverse on.
So when the electron flow starts from here, it has two paths to go. One is here, one is here. But then they'll identify that here the switch is
Open.
so they are not able to flow through it. So what happens is the current only flows through this path. So even if this diode is off, this diode will conduct. Here it's not the case. Electrons flow starts, here they'll stop. There is no flow of current. So current will not be.
Hope it is
One
clear.
question, right? Is it clear? This connection we call it series connection, and this is known as
Parallel connection.
in your house, right? You have to think that how these all equipments are connected, whether they are connected in series or they are connected in parallel. This is a parallel connection, right? This is refers to a parallel. This is refers to a series. So they are connected in series or a parallel.
It has to be parallel, yes or no?
Think, right?
Because if the light is not working, the fan will stop working.
We don't want the answer very quick, right? Because sir has already given you the hint.
But I'm still sure that they will need to think about it.
During lunch, you discuss.
Okay, so you're allowed to go for lunch. Hope you guys will come back, huh?
Yes, sir.
After all this. But hope I'm just waiting for. Should I wait for them or should I start?
It's okay, thanks.
Let's start, yeah? Okay. Good afternoon. So, hope you had good lunch, right? And as I said yesterday, I'll make sure that I make this session interactive so that you guys don't fall asleep, right? Okay. So, after understanding how your diode works as a switch, right? How should we bias? Now, we are actually going to look at the transistor that we use in the circuits through which we can realize the integrated circuits, right? So just look at this particular diagram at the moment. This complete structure is your NMOS, which is your N-channel metal oxide semiconductor, and we are going to understand that what is N-channel, what is metal, what is oxide, and what is semiconductor, right? So we are going to completely understand that how this works as a transistor now, right? Through which we can realize the digital circuits or we can realize any logic circuits, right? So this is like the basic block that we need to use. Understand? And what is drawn over here, that is the cross section of the center portion of it. Just understand like this, right? So in simple terms, how this device works is, just understand the complete structure first. Say this is a p-type substrate that we're using, right? What are the majority charge carriers in p-type? In p-type, majority charge carriers are holes, right? What about the minority charges? Minority charge carriers will be electrons, right? So just understand this thing. So let us say we start with this p-type substrate itself, right? So the majority charge carriers, they are holes. So can you imagine that it is all filled with positive holes over here on this side, on the substrate? All of you understand? Minority charge carriers will be electrons that will be also present here. So let us say in out of 100%, right? Let us say around 80 to 85% are holes. Rest of the 15% we have electrons over there. Understood? So now with that, the first and foremost thing that we need to do, N channel, because how this device will turn on, that is the first step. So what we need to do in order to turn on the device is, we need to bring the minority charge carriers which are present in this p-type substrate, and they should come and accumulate in this region. Let us say that we want this particular region to be filled with minority charge carriers. So initially this p-type substrate, it will be having holes and electrons which will be distributed, but now we want those particular electrons which are the minority charge carriers to be concentrated just in this region. So just think about it, that initially if you're p-type, it looks like this. Hope you're getting. So it is a combination of holes and there are electrons as well. So majority are holes, minority are electrons, and I want to do something to this so that this minority charge carriers, which are electrons, they should come and accumulate in this region. So ideally my structure should look like this later. Hope you're getting what we want to do. Now we need to understand that how we will do that. So is it clear what we are trying to do to all of you? Or you want me to explain it to you once again what we are trying to achieve? Please raise your hand if you're not getting it. I'm ready to explain it once again. Good. So understand once again what we are trying to do. Please be very attentive in the class, right? Although you have had a lunch, I want that you pay your 100% attention on the board. We have a structure which is N-channel metal oxide semiconductor, and just like your PN junction diode, now we are going to use this as a switch. So we were using PN junction diode as a switch, right? Instead of that, I want this particular device to act as a switch. How I'm going to do that? That is what we need to learn. So now, this is the complete structure of your NMOS, which is your N-channel metal oxide and semiconductor. The name metal oxide semiconductor comes from the center portion itself. If you look at this region, the first layer is metal, second layer is oxide, and the third layer, because it is completely made up of the silicon substrate, that constitutes your semiconductor, and that is why it is known as metal oxide and semiconductor. Now, what about this N channel? Where does this come from? Then, P-type substrate, it is a combination of holes and electrons, where your holes, they are the majority charge carriers. All of you agree with me? Right? So we have lots and lots of holes which are present over here, just as I said, right? So initially it will be a combination of holes and electrons which will be distributed randomly. Yes or no? Electrons will not be like this when we start. This is what we want to achieve later once I start giving something to it, right? So initially it will be like this, or maybe it might not be in line as well, right? It can be like this. So electron could be anywhere, right? And now I want to do something to it so that I can bring this electrons over here. So why I want to bring electrons over here? That is the first thing, because in this structure, when we look at the fabrication of this NMOS, what we are doing is, this is your source terminal, this is drain, and this is gate. So now consider it like this, that you have a tap, right? You have tap with you, and there is, it is connected to the water tank, right? So water tank will be considered as a source, right? Now you can only, the water can only come through the tap when you open the tap. Yes or no? So currently the tap is closed. So initially, if my electrons are not over here, I can say that my tap is closed. And the channel looks like this. So source, this is a water tank, right? Water will come from here, then it should flow through this region, enter here, and then over here we are putting a bucket. Hope you're understanding. Right. So there is a water tank here. You can open the knob through the gate, and there is a bucket which are connected at the drain terminal. Right. So the water can only come from the source and go to the bucket if you open the tap. All of you agree with me? Right? So first and foremost thing is, we need to understand that how we can open and close the tap. Right? Once you do that, then the next thing is, we I'm going to tell you that what needs to be done so that the water will start to flow, right? But first thing is we want the tap to be closed, right? So now, when can we say that the tap is closed? So in our condition, we want that the electrons which are minority charge carriers, which are like this, it can be anywhere. I want those electrons to be accumulated in this region. All the electrons which are present over here, they should come into this region. Why? Because this is also n-type, which is negatively charged. This is also negatively charged. Previously, there was no connection between this block and this block, because there were all positive charges in between. Yes or no? Because this is a complete p-type substrate. So majority will be holes, and holes will not allow any electrons to flow from here to here. Yes or no? Right. So the electron can only move from here to here if you also have something which is of the same type, which are electrons. So electron is like a bridge which you're creating in between these two. So this is like a road. This is one road. This is one road. This electron will enter from the source. Through this road, it needs to cross this one. Previously it cannot, because there is all positive holes over there, right? It can only pass when there are electrons in this region, so that it can flow through this region, enter on this side, and then from the drain we can collect it. Hope this is clear to everyone that what we want to do. So now the question, how can we bring the minority charge carriers, which are the electrons which are present in this bulk substrate, to be accumulated in this region? That is what we want to understand. So you already have understood about the p-n junction, that what we need to do so that the electron will start to flow in the direction, right? So if I ask you the same question, that this semiconductor, it is currently in this state. Now just think about it, that this is metal, this is oxide, and this layer is where I want these electrons to be accumulated. So can you tell me that what kind of voltage I'll be giving over here? Where should I connect plus? Where should I connect minus? That you need to tell me, so that the electrons which are present over here should get accumulated over here. See why it is not going to cross it? Because as I said, this oxide acts as a, oxide is what? Oxide layer is a insulating layer, right? It will not allow any current to flow through. So what you should understand is, I'm going to give some voltage in this direction, and I'm trying to bring the electrons on the top. Hope you understand, right? So electrons needs to come into this direction. Now oxide layer is an insulating layer. Why we are keeping it? Because we don't want those electrons to enter into the metal, otherwise it will be shorted, right? Is this scenario clear to everyone or not? Right. So now can you tell me that what kind of voltage should I give so that the electrons, which are the minority charge carriers, should come and accumulate in this region? Now tell me, how should I connect a battery? That is why we did the exercise of positive, negative, and the diode. Tell me, how I can attract the electrons? What I should do? Tell me, how electrons can come over here? Is the question clear to everyone? Sorry? Sorry? Parallel I'll explain later. You don't need parallel over here, so don't worry.
You just need to tell whether we are supposed to connect positive voltage or
Negative. And where? So here what should I connect? Should I connect positive or should I connect negative? That is what I'm after. Because I want the electrons to move in this direction. How can I attract the electrons? Through positive of the battery or through the negative of the battery? Positive of the battery. Very good, right? So at least you know that I need to connect positive over here, right? If I connect positive over here, which means, and this is anyways at the ground terminal, right? So ground terminal is connected at a negative potential itself, right? So this connection will look something like this only. Understood? If I'm doing like this, which means that the positive is connected to the gate, and then the gate is going to attract the electrons. Yes or no? Yes. And it is going to push the holes. Yes or no? Yes. Holes will be pushed in the downward direction while the electrons will be pushed in the upward direction. Hope you're getting. And we want to do that only. That we don't want any holes to be in this region. We want all the electrons, which are the minority charge carriers, to come and accumulate in this region. Right? Okay, if I give you one more example that will be doing three different things over here. Inversion. Inversion or depletion. Depletion तो कोई मतलब नहीं है, लोगों समझा वाला है ना? Fine. So we'll be discussing three different things. Let us say if you understand or not. But it is wise to at least discuss about it, right? So the first thing is, we have some terms. The first one is accumulation, second is depletion, and third is inversion, right? So let us try to understand with the first one, which is accumulation. Now I'm telling you that if I connect a battery like this, what will happen? Can you tell me? And especially I'm only interested in this region. What should happen because of this? If I connect a battery like this? Tell me. Holes will be there only, right? But if I'm giving a negative voltage, because the holes are currently very scattered, but if I keep on giving more and more negative voltage, more number of holes will come and accumulate in this region. All of you agree with me or not? Right? So what will happen is, that is because this was scattered. Now what I'm trying to do is, if I give a negative voltage are going to attract electrons or holes? Tell me. Negative voltage is going to attract holes or electrons? Holes. Opposite charges attract each other, right? So negative charges, they are going to attract more number of holes. So the hole density over here in this region, do you think that it is going to increase? Yes or no? Compared to this particular substrate, we can say that in this region more number of holes will be present. Because now I'm giving what kind of voltage? I'm giving a negative voltage, right? So because of this, I can say will this occur? Will this happen or not? All of you agree with me? So this is accumulation. We need to just understand that what happens. So what kind of biasing voltage we should give, right? So do we really want this to happen? If I bring more and more number of holes, do you think that any number of electrons which will enter from here, it will be able to pass through this? It will not be able to pass through it, right? So accumulation is something that we are not after. We don't want this. right? Now, what is depletion? Then, just understand one thing. Because initially, this one is still filled with holes only, right? The holes are distributed like this. Now understand that if I want the electrons to come and sit over there, which means that instead of the hole, I want the electron to come and sit over here, what I should do ideally? क्या करना पड़ेगा मुझे? Just think like this, that at your place, if I want him to come and sit at your place, what should I do? What should be the steps that I should follow? First, I need to tell you to get up from your place. You need to empty your space. Then only you can come and accommodate the space. Yes or no? Same thing needs to be done over here as well. You need to create a space for electrons so that it can come over there. So depletion, where did you heard this term depletion? Did you heard the depletion region term or not in PN junction? All of you? Agree with me? So when we were learning PN junction, just think about it that now we do not have N. We just have P, and we are creating a depletion just by the voltage that we are going to give. So can you think that if I need to bring electrons while moving the holes, what kind of voltage I should give? Again, accumulation, when I was giving negative voltage, I was bringing the holes. Understand? Because negative will attract positive. I do not want that. What I want is, I want the electrons to come over there, but before the electrons can come and occupy that space, I need to remove the holes from there. Yes or no? Right? So then what I should do? What kind of voltage I should start with? Negative or positive voltage? Tell me. Because now I want the electrons to start coming over there, but before my electrons can actually start to come, I want the mobile charge carrier, which is hole, I want that to move away. Yes or no? I want that space to be created. So in what condition I can make the hole to move downwards? What kind of voltage I should give? Negative? I will start with the negative voltage, but that particular negative voltage won't be that high. So it is like an intermediate stage we are talking about. So it will only be able to push the holes, but that voltage will not be strong enough to attract the electrons. Because you want electrons to be there. Yes or no? Are you getting or not? Or just saying yes, yes. I don't want that. It is a bit complex to understand. It is not that easy. So if you're not understanding, just say, sir, we are not understanding. Don't say yes, because if you not understand this one clearly, you will not understand the complete mechanism of how your MOSFET device is working. So again, the question is, I want my electrons to come over here, and before my electrons can come over here, I somehow want that these holes should be pushed downwards. So in order to push my holes downwards, what kind of voltage I should give? Negative or positive? Tell me. All of you should tell me now. Negative or positive? Holes किससे नीचे आएंगे? All of you understand Hindi? Yes, sir. Because I think English is creating some problem. हाँ? ऐसा कुछ हो रहा है क्या? I don't want that to happen. Language is not a barrier, okay? I'm good at Hindi and English. So if at all you are not understanding something, I'm willing to teach you in some other language as well. So again, I want to bring the electrons, but before bringing the electrons, I want the holes to move downwards. So what kind of voltage I should start with? Negative or positive? That is a question. Huh? Positive voltage. Very nice. So now, because we are in a depletion stage, which means that holes should be moved, but the electrons are not yet reached that particular location. Right? So when we were learning about the PN junction, so just understand that this was your P and this was your N. And now you only have this thing with you. You do not have this. And this is what I am turning it in this manner. If you understand it, then what is happening is, if you just look at this particular portion, can you imagine what is happening? And don't you think that this is exactly what we are trying to understand over here? Yes or no? Because this is a P-type substrate. Understood? So this was your P-type, right? Exactly the same thing if you are just turning it. And this region was which region in equilibrium? We are calling it as which region? When we are not biasing. When we just bring the PN junction together. That region was known as what? Depletion region? Yes or no? I think you guys are not taking any notes. That is why you are not catching up with me. For the PN junction, what was this region? All of you check the notes. Huh? Depletion region, right? And that is what we are trying to understand over here. What is depletion? So don't you think that we want to create something like this only over here? If we try to understand depletion, I should also make something like this. Instead of this plus, I should try to bring this kind of sign over here. And what was this? This depletion region is nothing but it is devoid of any mobile charge carriers. So we understood that when electrons were moving over there, the net charge was becoming negative over there, right? So this region, just keep it very simple. This will be holes, and this are nothing but immobile charge carriers. They cannot move, right? And whatever is present in this region, that is why it is known as a depletion region, because it cannot move. So depletion region is devoid of any mobile charge carriers. So mobile charge carriers are only holes or electrons. If there is no hole and no electron present in this region, that region is known as a depletion region. And that is what we want to create first. Which means that when you get up from your place, that particular condition is known as a depletion at the moment. Because you are not there at the moment, right? So consider you are a hole and he is electron, right? So when you are getting up from your place, before he come and occupy your place, that space, what is that known? That is known as a depletion region. Hope you are clear, right? So that is what we are trying to understand over here, that initially it was filled with holes and now we started to give the positive voltage, right? So now I should change over here that we start with giving a positive voltage. So when we start to give the positive voltage, but this particular positive voltage, it will be small. So when I am only giving a very small positive voltage, it is only going to create a depletion region. It will not attract any electrons over there. Hope you understand this thing, right? Next is, if I keep on increasing the value, what will happen now? Because now I already created the depletion. Getting?
Because it mostly apply the force up to down.
Fine. Now this happens. Yes. So when we start giving more and more positive voltage, what it will do is, because we already have created the depletion region, which means that now there is space, right? That was intermediate space, this depletion. So now space is there. Now all we need to do is, if we start applying more positive voltage, the electrons can come and occupy that space. Yes or no? Right? So first I need to empty all these 5 chairs. I need to tell them that, okay, you get up please. So if you are whole, I need to tell you to get up from your place. I need to empty that space. Whenever I'm emptying that space, that is your depletion region, right? And when I tell that, okay, the students on the second bench can come to the first bench, that is known as the inversion. Why inversion? Is because initially the complete substrate was positively charged. Yes or no? Majority of them in this region was all positive. But what I have done is, I have inverted the charge from positive to negative in this region, because ultimately, if I keep on increasing the voltage, we have electrons in this region. So instead of the positive, so this region, which was initially positive, I have inverted it to negative by bringing all the electrons there. And that is why the name is known as inversion. And when that occurs, we can say that device is now in an on state. We can say that now the tap is on. Clear to all of you or not? Right? So in order to clear the tap, to turn on the tap, we need to bring the electrons over here, which are the minority charge carriers. Clear? So I'm giving you 5 minutes to digest all these things. You please at least look at what we have discussed so far, especially in terms of the voltages. Start giving the voltages. So this is small positive voltage. Again, I'm going to give a positive voltage. Which is large. So think in terms of this, that over here for the accumulation, I'm giving negative. So what happens in the accumulation, what happens in the depletion, and what happens in the inversion, based on the biasing voltage which we are applying. Pandit? So the ideal way to learn this is, when you're trying to understand accumulation, what you should do is, you first give the negative biasing over here and see that what will be present in this region. You should draw that. Similarly, for depletion, you draw one more and you give the biasing over here, and then you see that what will be present in this region. And for the third one, which is inversion, again, you draw the third one. We will see that now you are giving more positive voltage, and because of that, now what will be present in this region. So instead of writing all the semiconductor P type, you should ideally draw something like this for your structure so that you understand all the 3 different steps. Unless and until you draw it, you will not understand this. So start drawing it. Chalo, for the accumulation, tell me, what will happen? Tell me, what should I connect over here for accumulation? What kind of biasing voltage I should give? Accumulation, which means what? We are trying to bring what? Holes or electrons? Tell me. Holes, right? So if I want to bring holes which are already present over there, what kind of voltage I should give? Because I want to attract holes over there. So tell me, what kind of voltage I should give? It will be negative, right? So when I give negative over here, like this, more and more number of holes will be here. Right? Over here it will be distributed as it was previously distributed. There will be no change over here because whatever is happening, that is happening near the junction only. You should understand this thing. Because if we look at it, then there is nothing which is happening over here. So usually when I teach, I tell my students that this particular region I call it as my active region. Because that is the region in which I want to create my channel, which is this region. Right? And rest of the region, I call it as bulk. So you will understand that in all 3 things, whatever voltage we are going to give, there will be no change in the bulk. Whatever change will occur, that will occur in the active region itself. Hope you are getting now. Right? So I am only interested in you showing that what will happen in the active region based on this accumulation, depletion and inversion, and our final goal is that we want our tap to be on and that the channel should be created. So I want my electrons to be present in this active region. So do I currently need any plus or any holes over here? I don't, right? What I need is, I need electrons over there. So what is this intermediate step now? Now again, when you're trying to check the depletion, you should check in this manner itself that this was distributed like this only. Because we haven't started giving any biasing voltages over here, right? So my p-type substrate, all the holes will be like this, right? There's some electrons scattered somewhere like this. Maybe 1 electron will be there, but that won't be enough to carry any current, right? So just understand this thing. So now the next step is what? Depletion. And depletion, you need to think like this, that we don't have any mobile charge carriers over there, which means I don't want any plus over there. So I need to push my holes downwards. If I want to push my holes downwards, what kind of voltage I should give? Positive voltage, right? Because positive, positive, they will repel each other. So when I start giving the positive voltage, what will happen? This particular holes, they will be pushed downwards, right? And what will be left over here? Because this voltage which I'm giving, that is a very small positive voltage I'm giving. Understood? So when I'm just giving a very small positive voltage, it will only be capable of moving the holes. Understood? Now, think about the inversion. If I give more positive voltage, so what will happen now? Because these electrons are negatively charged. Just understand this thing. So if I give a positive, more positive, what will be more attracted? Electrons will be more attracted over there, right? So that is why if I start giving more and more positive voltage, because this was a depletion state, right? And there were no holes over there. So instead of holes, now this depletion was there and the space was empty. So the electrons will come over here and it will occupy the space. Understood? This is inversion. So why it is inversion? From the positive, this all was initially all holes were there. Instead of holes, what we have done is that we have bring the minority charge carriers, which are electrons, all to accumulate in this region. So from positive, we change the potential to negative. And that is why this process is known as the inversion process. And when that is done, we can say that now, once the channel is formed, this device is in the on state. Understood? Okay, so now a question to all of you. What will happen if I change the substrate from P type to N type? If I change my substrate from P type, currently it is P type, right? So in P type, my majority charge carriers were holes, minority charge carriers were electrons, and I was making the channel using minority charge carriers. Yes or no? So now if I change my substrate from P type to N type, what will be my majority charge carriers in N type? Electrons will be my majority charge carriers. What about the minority charge carriers? Holes. So now if I want to make a channel over here, what I should do? What should I change now in the structure? Can you tell me? This was initially P type, right? So can you now try to change what you need to change in the structure? If I want to make it, instead of NMOS, I want to now make it PMOS, which is a P channel metal oxide semiconductor. Hope you're understanding. So then what I should do now? What I should change in this structure? Can I keep this N over here or not? Tell me. Can I still keep this N? Because now at least you should know that we are going to bring holes over here. Yes or no? Because it is a P channel MOSFET. P channel, which means it will be made up of holes, because holes are positively charged. So if I'm bringing holes over here, I cannot keep N over here. Yes or no? Yes. Because if I create a channel, if still it has N, then there will be no flow of current. I need to make it of the same material only. So then this should be replaced by what? Instead of N, it will be replaced by? Very nice. So this will be replaced by P. So now I want you to understand that what kind of voltage I should give so that I can bring the holes over here. Do the similar analysis. Is the scenario clear to everyone? What we need to do now? Instead of N channel, now we want to create a P channel. So P channel is formed of holes. So you need to think that over here now how you can bring the holes which are the minority charge carriers, because now you are taking N type. It will be initially like this, yes or no? Because this is N type. In the previous case it was P type. So in this one the minority charge carriers will be holes. All of you agree? And you want those minority charge carriers to be accumulated in this region instead of the electrons. So now think about it, that what kind of voltage you need to give so that that will happen. You don't need to understand this accumulation. Accumulation was just for your understanding that what will happen because of the biasing. You're only interested in creating depletion region followed by the inversion. Yes or no? Right? So at least for this two, tell me that what kind of biasing voltages you will give. You can take your time. So you can change the respective voltages over here because it will be exactly opposite now. Just think in this term itself. This PMOS works exactly opposite to that of your NMOS. It is as simple as that. So whatever you understand for NMOS, just think exactly opposite for PMOS and you will get the answers. Not getting? What happened? Huh? So if you cannot do this, which means that you haven't understood the first one. It is as simple as that. Because as I already told that this is exactly opposite to the first one. So if you're not in a state to do this one, which means that you haven't understood the first case itself. Tell me.
Sir, I think negative need to be added to attract methods.
Negative one. Yes, perfect. Exactly. That's what we need to do. We give the negative voltage over there because we need the holes to be accumulated over here. It is as simple as that. Understood? Because lots and lots of electrons are over here because it is n-type. Minority charge carriers are holes. If you want holes to be accumulated over here, you need to give negative voltage. That's it. Because previously you were bringing electrons. And for electrons you are giving positive voltage. Now if you want to bring holes, you need to give negative voltage. Very easy. I mean, don't get confused. Just you should be clear with what needs to be bring to this channel region. If it is holes, you give negative voltage. If it is electrons, you give positive voltage. That's all. Clear? So understand one thing, that the name is given based on the channel. So if somebody asks you PMOS, it is P channel MOSFET. Channel is of P type. So if the channel is of P type, the substrate will be of which type? It will be opposite. Yes or no? Because channel is made up of the minority charge carriers. If the channel is made up of the minority charge carriers, the substrate will be exactly opposite to that, which means that it will be of the majority charge carriers. Right? So for NMOS, if it is N channel MOSFET, what will be the substrate? N channel, which means it is formed of what? Channel is formed of what? Electrons. Electrons are minority charge carriers. Majority charge carriers will be holes, right? So holes, what type of semiconductor is that? No, that's okay. Yeah, sure. Yeah, tell me. Yes, so we are discussing about the difference between so this one is NMOS or PMOS? Which one is NMOS and which one is PMOS? And tell me why. So you need to map. So let us say this is A, this is B. Is this correct? You need to justify why this is called as NMOS. So what is the full form of NMOS? It is N channel metal oxide semiconductor, right? So metal oxide semiconductor comes from this name itself, which is the metal layer, oxide layer, and the complete semiconductor is there. So from the center itself, this is metal oxide and semiconductor. The channel which you are forming gives the name NMOS or PMOS. So if you are forming a N channel which is due to electrons, then it is known as N channel MOSFET. So if you are forming a channel using electrons, the substrate, so this I'm calling it as a substrate. Substrate will be of which type? That is the question. It will be of P type or N type substrate. Tell me. So you should understand that for NMOS, which is N channel, N channel electrons are minority charge carriers. Substrate is always made up of majority charge carriers. Understood? So for NMOS, substrate will be N type or P type. Tell me. Substrate will be of P type, right? Because it is the majority charge carriers are holes and minority charge carriers are electrons over there. That is what we have studied, right? So if this is the case, which is a P type substrate, because over here we are bringing all the electrons, yes or no? And that is why it is known as N channel. This is known as a channel. We are forming a channel between this region, this source region, and the drain region. Hope you're understanding, right? So whatever channel is formed of, that is a minority charge carriers. So whatever are the majority charge carriers, that is what is the substrate made up of. So this is your substrate. Understood? Similarly for PMOS, if we do the same thing, then for PMOS, the channel is what? Let us change it. For PMOS, channel will be what? It will be P channel. Minority charge carriers are electrons or holes? Huh? If holes are the minority charge carriers, what about the substrate? Substrate will be having what? Electrons, right? If electrons are the majority charge carriers, then the substrate is made up of N type or P type? N type, right? Because electrons, they constitute this N type substrate. And as you can see from here, this is your NMOS and this is your PMOS. So over here, the channel will be all positive. Oh, bahar gaye. Is it clear to everyone or not? Huh? Any doubt? That how to understand the name? You shouldn't be confused. This PMOS and NMOS, the name P and N is the name given to the channel. I mean, whatever the charge carriers are present in the channel. So the substrate will be opposite to that of that carriers which are there in the channel region. Hope it is clear. Any doubt in understanding the name? So now one thing is for sure that if we consider this NMOS, we started to give positive voltage. Yes or no? Because when we apply positive voltage, then only the electrons will come over here, which means that the channel is formed. That is the very first step. So when that occurs, we can say that the device is in the on state. Now when the device is in the on state, the second thing is, now we want the current to start flowing, because till now we haven't done anything to the source region and the drain region. Yes or no? We are only applying voltage to the gate. This G is nothing but the gate terminal. S is source, D is the drain. Right, so now what I need is, as I was telling, that most of the water is filled over here. So just understand, source, it is having lots and lots of electrons over there. Right, now once the channel is formed, what I now need is, I want the electrons to enter the source region, it should travel through this, and then you should be able to collect it over here. If you want to do that, what kind of voltage you will be providing at the drain terminal? That is the question. So understand this thing. You want to give some voltage at this terminal so that it will be able to attract the electrons which are at the source terminal, and currently the source terminal is grounded. So grounded, which means that it is, usually because it is we keep it as a negative terminal, right? So you only need to keep one thing in mind, that there are lots of electrons available over here. You want that electron to be traveling from here all the way to here and to the drain. So then what kind of voltage you will apply to the drain so that the electrons will move like this? Tell me. Should I give a positive voltage at the drain, or should I give a negative voltage to the drain? We will give positive voltage. Excellent. I think you have already understood now. Getting better. So two things we did. Understand. First is, we applied a gate voltage, which is a positive voltage, so that the electrons will, which are the minority charge carriers, they will be attracted and they will form a channel. Once the channel is formed, then we will apply the voltage across the drain with respect to source. Because this is connected to the ground, this is also connected to the ground. So usually we call this particular voltage as VDS, which is drain voltage with respect to the source. Because as I was telling, that the circuit should be complete, then only the current can flow. Yes or no? Right? So just imagine that this is connected to the ground. This is also connected to the ground, which means that this terminal and this terminal, they're connected to each other. So in short, positive is connected over here and negative is connected to the source. Hope you're understanding. Right? So like this, in the two-step, you can say that this particular device will work. Clear? So first is the gate voltage that we apply, through which we will create a channel. Once the channel is formed, you start giving the positive voltage, so the electrons will enter from the source region, it will move through the channel, it will enter the drain end and over here. Clear? This is the working of NMOS. So now can you think about the working of the PMOS? What should we do? Because now you are talking in terms of volts. This is not very easy to understand. PMOS is not that straightforward to understand as compared to NMOS, because now you are talking about, you have holes in here. So what kind of voltage you should give? That also you need to understand, and where exactly you will be giving that voltage. આના પછી પેલું ફેબ્રિકેશનનું બતાવી દઈએ નહીં હવે, પહેલાં બુલિયન કરાવી દો એ લોકોને. હવે એમનામાં એઝ અ સ્વિચ તો પેલું ખબર પડી ને, હવે પેલું કરાવી દો તમે. It's fine, you can try to go through this at your home right now, because I think you guys are in saturation mode. Yeah, I can clearly understand that, and it is absolutely okay, because this is what will happen. Your art student learning NMOS and PMOS is like a next level thing. It is like you will be teaching me arts and history. I mean, I'll go crazy if I sit over there and you come over here and you teach me. So same thing will be happening to you as well. But I'm at least I can make it out that you are getting something out of it, right? So now I'm going to call Ankur sir. We'll be having some simple things.
You want break 5-10 minutes?
Do you want a break?
Yes.
5 minutes?
Yes.
Please take a break. Go wash your face so that you come back to the same zone, right? Do that. Okay, quickly, 5 minutes.
Okay. Logic behind it. So yesterday we saw a video where the billions of transistors were implemented on a chip. Right? Though there are billion transistors, but for digital circuits, the main logic is switching. Okay? Switching, so for example, any switch has two states. Either it is on or off. So this is the basic logic we use to build a circuit. Right? You'll be surprised a bit here, but this is true. Right? And this can easily be mapped to the semiconductor devices like diode. If it is forward bias, diode is on. If it is in reverse bias, diode is off. So it's basically a switch. The MOSFET you studied, if you apply the positive gate voltage, MOSFET is on. If you apply the negative voltage, the MOSFET is off. Okay? And then the logic we use behind this is Boolean logic. Right? So you would like to see how the Boolean algebra works, how the Boolean algebra is different than your normal mathematics, right? And how we can use it to implement certain circuits. Okay? So before we go ahead, let's understand again the difference between digital and analog as well, right? This is for digital circuits and not for the digital and analog. How do you differentiate? You know what is digital? I mean, you heard digital and analog? Yes or no?
Yes, sir.
Analog and digital? So what is the difference? Anyone? Analog?
Mechanical parts or maybe some second watch.
Okay. So the watch with hands, we basically call it analog watch. But when you see the digits, right, you call it digital, right? But actually, it's not in that sense. We'll understand it. Okay, I'll give you one example. Have you heard, let's say you would like to, I told you to measure the outside temperature throughout the day, right? I have given you a task to measure the temperature. Let's say this room temperature. So what will you do? You need thermometer to measure the temperature. You know thermometer, right?
Yes.
Okay. thermometer will give you the temperature reading. You'll come at some time, measure it, note it down, and when you note it down, you'll also note the timestamps. For example, at 9 a.m. this was the temperature, so you attach the timestamp with your reading. Yes? Correct? Okay. So how will you do that? I mean, what is the time interval you'll choose? Just, do you think within, let's say you have chosen 1 hour. So how will you proceed? You'll come at 9, take the reading, then you'll come back at 10, you take the reading. 11, you took the reading. Done? And throughout the day you'll do this exercise. You'll present one very nice table where the time and temperature is mentioned. Right? Then you come back to me and say that, sir, we have taken the temperature data of this room for throughout the day. So I'll ask you immediately a question. So tell me, what was the temperature at 9:30? Now you have not taken the reading at 9:30. Right? So what you have done, you have taken one reading at 9, second is 10. You don't know what happens in between. Right? Let's put on some numbers so to understand this. So for example, at 9, let's say temperature was 19, and when you came back at 10, temperature was 21. Okay, not a huge difference, right? So throughout the day you have made this table. Now the question is, I asked you what was the temperature at 9:30. So what will you do? Sir, we have not taken the we didn't at the reading at 9:30. We took the reading at 9, we took reading at 10, but tomorrow we'll come back and we'll take the readings at 9:30 as well. So tomorrow what you will do is, you'll reduce your time period. Okay? For example, for this we have taken the time period of 1 hour. 9, 10, 11, 12, 1, 2, 3, 4, 5, like that. Right? Now what you have done, you have reduced it to 30 minutes. So you'll take reading at 9, 30, 10, 10:30, 11, 11:30. Is it clear? Yes? Okay. Now you again prepared the table, same table, right? You came back to me, sir, we have taken the readings. I asked you what was the temperature at 9:15. So again we don't have that reading. So if you see all these readings, they are discrete in nature. Discrete matlab, we have reading at one time and then the next reading is at some different time. We don't know what happens in between. Those systems are basically, those kind of signals are known as digital signals. In analog signals, generally what happens is we have a continuous time varying signal where we have the information about the temperature of the throughout the day. Just to give you an example, let's say this is time. You understand the graph, right? Simple graph, yes? Here you have temperature in degrees Celsius. This is 9 a.m. to 9 p.m. This is around, let's say, 2 p.m. So initially temperature was, let's say, 18 degrees Celsius. it rises to some value and again come back. Now if I ask you what is the temperature at 9:15, what you can do, you can zoom around this area and you can find out what is the temperature. Yes? 9:30, you know, you zoom around this and you get the temperature. But what we have done is, we have taken one reading at 9. We came to know that the temperature is 18 degrees Celsius, right? Second reading at 10, which is 21 degrees Celsius. One more at 11, for example, it is 23 degrees Celsius. But we don't know what happens between these two time samples. We don't know what happened, what was the temperature between 9 to 10. But we can predict it. For example, if temperature is at 9 at 18 degree and 10 is 20 degree, for example, right? So what will be the temperature at 9:30? If temperature at 9 a.m. is 18 degree and 10 a.m. it is 20 degree, for example, right? So what will be the temperature at 9:30? 19 degree. You can predict it, right? You can average it out. So it will be around 19 degree. And even if it is 19.2 degree, for example, the actual temperature is 19.2 degree. So we have the error of 0.2 degree, right? Which does not going to, cost us anything, right? It's okay. Yes?
Yes, sir.
So all the natural signals that we have are analog in nature. They are continuous with respect to time. True? When I speak, the voice signal, is it continuous? If it is not continuous, there is voice, no voice, voice, no voice, right? You will not understand it properly. It's a continuous in nature. True? It's not a discrete, right? But digital system will convert it into a discrete signal, and then the discrete signal will be encoded with binaries. You know binary number systems? Have you studied the binary? What is the decimal number system? The one which we are using. Digits 0 to 9. Those are the decimal number systems, right? Binary has only 2 digits, 0 and 1. Binaries have only 2 digits, 0 and 1. Now let's try to connect all this together. Okay? Digital circuits uses the binary. Binary has 0 and 1. And Boolean algebra also answers in yes or no. Any question has only 2 answers. Either, for example, would you like to have tea? What will be the answer? Yes, sir. No, I don't want to investigate further. I just want to know whether you would like to have a tea or not. You say yes or no. That's it. Done. Have you done homework? Yes or no. That's it. So that is the Boolean. Is it clear? Yes. So Boolean algebra has only yes, no, true, false. Okay? Let's do some exercise on that. You can note this down, right? This will help you to understand further, right? So Boolean, if we have any Boolean variable, let's say A, it has only two value, either 0 or 1. 0 basically refers to a false, 1 basically refers to a true. One of the example is no, yes, switch is off, switch is on. Now you should be able to connect all the dots, right? We use a semiconductor devices like diode, MOSFET, which can work as a switch. Switch could be on, off. Switch could be, now that on off logic can be easily mapped to true and false of the boolean, right? When we switch from logic to a circuit, we need some number system which help us to implement everything, and that's why we use binary, because binary has only two digits, 0 and 1. So 0 can be mapped to false, 1 can be mapped to true. Okay? Any question as of now? 0 means false, 1 means true, right? 0 means no, yes, right, on, off with respect to switch. Okay? Okay, let's understand the Boolean functions. So various functions we use in a Boolean are AND, OR, NOT. These three are the basic Boolean functions: AND, OR, NOT. Right? Let's understand this. So AND function, for example, let's take in one example, right? You have to tell me here we have one switch S1, another switch S2, and here we have connected one bulb. Okay? Here we have the voltage source. Okay, so we have bulb here, LED bulb, let's say, voltage source, and two switches are connected like this. This is a voltage source, electricity, right? Okay. When this bulb will be on? When this bulb will be on? We have two switches, S1 and S2. What should be the switch? On, off, क्या होना चाहिए switch to turn on this bulb? On. S1 on, S2. You got my question? We want this bulb to be on, right? One end is connected to a source, one end we have a bulb. In between we have two switches, S1 and S2. What should be the state of those two switches to bulb to be on? It's very simple. Both has to be on. Will bulb be on if S1 is on but S2 is off? No. Right? Will bulb will be on if S1 is on but S2 is off? No. S1 off but S2 is on? No. Both switch has to be on. And how do you tell it that in simple language? S1 and S2 have to be on. Must be on. Yes? This basically creates a AND function. You understood what is AND function now? For AND function, S1 and S2 have to be on. So this is a AND function. Any question? You understood AND? It is called AND function or AND logic. Done? Okay. So now let's look into this way. Switch S1, if it is off, the binary value that we assign to this switch is 0. Right? So if switch S1 is 0, that simply means it is off. Okay, so we'll map it like this. The binary logic will be, binaries, numbers will be mapped to a logic like this, right? So off is mapped to 0. If switch is on is mapped to 1. So for example, if I write down like this, S1, S2, and here we have bulb state. When I say S1 is 0, the value of S2 is also 0. That means S1 is off, S2 is off. Whether bulb will on? No. So bulb is also off. So also bulb output is 0. Is it clear, everyone? If S1 is 0, S2 is 1. What does this mean? Switch S1 is off, switch S2 on. But whether bulb will turn on? No. So what is the output? It's easy, right?
Yes.
1. It's really easy, right? S1 on, S2 off. Whether bulb will turn on? No. Then again bulb output is 0. Off is basically a map to 0. Okay, 1, 1. Now the bulb will turn on, right? This basically a logic, this logic basically refers to a AND logic. So switch S1 and switch S2 has to be on. Done? Okay. If you understood this, I want you to answer this. What will be OR? Huh? OR. How does OR logic will look like? And you understood? Right? And you understood. Okay. Let me redraw the two switches, right?
Yes, sir asked a question, right? And he wants the two students should compulsory answer the questions. That is, and that is what you learned, right? In or it will be either of those students can answer. That is still okay. I mean, that is the hint. Now you can check.
Okay. Now you tell me. OR. So we have two switches. Let's call the top one S1 and bottom one is S2. Fact is, when bulb will get connected to supply, right, it will be on. Okay. Okay, let's understand this. Let's say switch S1 is off. switch S2 is also off. Whether the bulb is going to turn on? No. True? Yes, both switches are off. Bulb is not going to be turned on. So what is the condition to turn on the bulb? Looking at this diagram, what is the condition? Let's discuss this. For example, S1, switch S1 is on, but S2 is off. Whether the bulb is going to turn on? Yes, it is true, right? Why? Because supply will get connected to bulb through this path, right? So S1 is on, this is off, still the bulb will turn on. Okay? Ulta. S2 is on, but S1 is off. S1 is off. Whether the bulb is going to be turned on? Yes, in that case also it is going to be turned on, because the supply now will reach to bulb through this path. True? What if both switches are on? Still the bulb is going to be on. So when the bulb will be off? Both switches are off. Okay? So to turn on the bulb, what is the logic here? Either S1 or S2 has to be on. That basically creates the OR logic. You're saying OR, and right, either S1 or S2. Is it clear? Is it simple? Yes or no? Yes. Right? It's really simple, right? This is the simplest things, I mean, we can get in digital designs, right? Okay. Okay, you have to tell me either 0 or 1. 0 or 1? 0. Why? Because bulb is off. Very good. On. Bulb will be on. Because S2 is on, that simply means the current will reach to bulb. Okay? Yes or no? One. Okay? Now, the AND logic in math, Boolean math, we generally use AND symbol to represent it. Okay? And OR logic is basically represented using vertical line, right? If you don't like to use symbol, you can write down AND and OR. Okay? Okay. Second thing. So this logic, basically, the switch logic can also be written as S1 and S2. Whereas this switch logic can be represented as S1 or S2. Done? Okay. Not. This is slightly trickier, huh? Okay, first let's understand what is this, by the way. What is this? What is it? What supply voltage you get at your home? Supply voltage? Electricity? Why? Why you are not getting supply voltage? Not getting electricity? Huh?
Not aware of that.
No, okay, not aware of this, right? Okay. So let me tell you, if generally, if it is AC supply, it will be a 240 volts. Okay. So again, supply is like on and off. You get the supply, you get 240 volts AC, and that basically refers to a ground where there is no supply or 0 volt. Ground basically refers to a 0 volts. So 0 volt means no supply and the bulb will not turn on. The bulb will not turn on. Is it clear? Yes or no?
Yes, sir.
Okay. Again, let's say I have switch S1. When the bulb will turn on, when the bulb will turn on, we know that to turn on the bulb we have to connect 240 volts, which is this supply, and it should not get connected to a 0 volt. So what should be the state of the switch for bulb to be on? Switch has to be off. If switch will on, let's say for example this switch is on, what happens? Bulb will get connected to a ground. Yes? And bulb won't turn on. So if switch is on, the bulb is off. Ulta. That's why it is known as a NOT logic. If switch is off, bulb will on. If switch is on, bulb will be off. Ulta. Is it clear?
Yes, sir.
If switch is off, bulb is on. Switch is on, bulb is off. Done? Quick question? No? You have any questions?
She wants to rest 5 minutes.
So there are three basic functions that we have: AND, OR, and NOT. Okay? Let's see how we use this in a real world. Okay? Okay. Let's say we are designing a system which will tell us whether we are supposed to take an umbrella or not. Today I am going to the office. That system will notify me whether I should carry an umbrella or not. Simple. Right? When I ask a question to that system, whether should I carry the umbrella, the answer will be either yes or no. Done. Okay? So that system will ask me something, right? For example, whether you are going on a bike, whether you are going by walk, or taking car, so that some feedback will be needed to a system, right? Okay. So I'll just tell you what that system is. So for example, this is that system. Okay, we don't know what is that. It's simply a black box that we would like to design, and it will tell us whether I am supposed to carry an umbrella, right? So the answer is either yes or no. But it takes 3 input first. First input is whether I am going to take by my car. If I go by car, it doesn't matter whether there is going to rain or not rain. I don't need umbrella because I am going through car. Yes? Right? Anyone sits in the car with umbrella open? Anyone? No. Right? As long as we have roof in the car, right? Okay. Then it takes another signal whether there is a raining or not. It also asks me whether outside, whether it is raining or not. Okay? Yes?
Yes, sir.
And then the third one is a rain forecast. Whether rain is forecast. Okay? So what should be the logic? Chalo. What should be the logic? Just think. Which Boolean function should I use to implement this logic? Or, okay, so one function will be or, but or between what? I have 3 sources to make the decision. One is rain, rain forecast, and car. Sorry? Rain. So see, or logic is between 2 variables, right? Or is S1 or S2, and is S1 and S2. So you have to combine 2 together. Okay? So I'll give you the skeleton. For example, this black box will look like this. So here you need one logic, you need a one logic here, you need a one logic here, and then you'll get the whether you are supposed to take the umbrella or not. Here it will be a rain and rain forecast, and here it is car. So for example, how does it work system? If outside it is raining, then the rain will be, the value of rain will be considered as 1. It is true. Whether rain is forecasted, it is 1. If rain is not forecasted, then the signal is 0. This signal is 0. If there is a no rain outside, the signal is 0. If I am taking my car, this is 1. If I am not taking my car, it is 0, like this. Now you just need to think what logic you will use. If I take my car, do I need umbrella? No. Right? If I don't take car, I might need an umbrella. True? So here the logic is not. Ulta. If I take car, I don't need umbrella. If I don't take car, I might need umbrella. So its logic is ulta, not. Right? Switch is on, then the bulb is off. But switch is off, then the bulb is on. It's a ulta. Yes? You got it? Okay. If outside it is raining, do I need umbrella? Yes, I need umbrella. If outside is raining. If rain is forecasted, still I need umbrella? Yes. But what if rain is not forecasted and currently outside it is not raining? That simply means both the signals are off. There is no rain and there is no rain forecasted. So what is that logic? I have to take umbrella if outside it is raining or rain is forecasted. What is that logic? Or. Right? So here you have to use or logic. And then again, or here. That's it. Let's take one of the case. There is a rain forecasted. Rain is forecasted. Okay. So what is the value of this signal? Rain forecast 1. Outside it is not raining. What is the value? 0. This is OR logic. One input is 1, second input is 0. What is the output? 1. Right? One of them has to be 1. ये आपने ही लिखाया है, right? 1 minute. You can see that if one of them is 1, the output is 1. True?
Yes.
As a tea break. If they want, huh? If you feel interesting, then you can continue.
So let's finish this in 5 minutes and then we'll, okay? So if there is a rain, it is 1. Rain forecasted, it will be either 1. Okay? So whether there is a rain or rain is forecasted, in either case I am going to take the umbrella. So how do I combine them? Using OR logic. Is it clear? Yes or no? Right? So any one of them is true, I have to take an umbrella. Second, if I am taking my car, I don't need an umbrella. So there the logic is not. But if I am not taking the car, I need an umbrella. Yes? And in either case, if this is true or this is true, I have to take an umbrella. Right? Okay? So how does this work? For example, there is a rain. This is 1, this is 0, and this is also 0. If this is 1, 0, what is the output here? 1. This is 0, not. What is the output? 1, not, ulta. If input is 0, output is 1. If input is 1, output is 0. Done? This is OR. Both inputs are 1, 1. Yes. I have to take my umbrella. Right? The system will just tell you that. This is how Boolean logic will be used to implement any digital circuits. Okay? Let's break for a tea. We'll come back.
I was in the So now, what this NMOS and PMOS you learned, that is what is actually being used to realize this case. So you should have some connection, right? That's why you learn this one, right? But then all this
as invert, right? Because it does the exactly the opposite of what input is, right? If input is 0, the output is 1. If input is 1, the output is 0. Okay? So these are the Boolean functions. So in circuit, what we do is we use a gates. We call it a logic gates. To implement these functions, right? So I'll just go through a few symbols of it, right? So for example, we have AND function which can be implemented using AND gate, AND logic gate, and then the symbol of AND gate is something like this. Here you have two inputs, for example A and B, and then the output is F. Okay? So in circuit, whenever we use this gate, it creates the AND function between two input A and B. So its Boolean expression is A and B. And then a table which shows the input and output basically. So these two are A and B are the inputs and F is the output, are basically refers to a truth table. So this table is known as truth table. Okay? Let's understand this. So if I have AND logic, if both inputs are 0, what is the output? We discussed this. For AND function, to turn on the bulb, switch S1 and switch S2 have to be on. Both has to be 1. Otherwise, right, 1 means on. Right, on is mapped to 1, off is mapped to 0. So 0, 0 is, the output is 0. 0, 1 is also 0. 1, 0 is also 0. But 1, 1 is 1. Okay? So this is refers to a AND gate. So we have one software, we call it Logisim, where we can make those circuits and we can simulate and see whether the output is changing accordingly, right? So I'll demonstrate it. I'll show you that after this. Okay? Okay. Second is the OR gate. So its symbol is something like this. F is equals to A or B. And let's understand this. Now OR gate, we know that this either switch S1 or switch S2. One of them has to be on. Yes? So what is the logic that if both switches are off? Off. But if one switch is on? On. One, zero? On. On is mapped to now 1. Off is mapped to 0. 1, 1 it is 1. Okay? Any question? Okay. And last one is the NOT gate. And if input is 0, the output is 1. And if input is 1, the output is 0. It's very simple. It inverts. Input 0, output 1, input 1, output 0. Okay? Now you need to understand little bit about the Boolean variables. For example, here A and B are known as the Boolean variables. So if I have two variables, there are 4 possible combinations, right? Both of them will be 0. One will be 0, one will be 1. Another will be 1, another will be 0, B will be 0, or both of them will be 1. How many combinations we get if I have 3 Boolean variables? 3 Boolean variables. Just think. We have 3 Boolean variables. How many combinations we get? If I have 2 Boolean variables, combinations are 0, 0, 0, 1, 1, 0, 1, 1. What if I have 3 variables? After, this 2 days, at least I know that you cannot think this, right? You have to write something, you have to identify. If you keep on thinking, the answer won't come out, right? You just write down 3 variables, A, B, C, for example, and then try a different combinations, right? You are not supposed to repeat the combination. I am not repeating any of the combination here. All of them are different. Right? So you same way you write down 3 variables A, B and C and try different combination and see how many combinations you get. For example, A, B, C, all of them are 0. 0, 0, 0. Next combination could be 0, 0, 1. It's possible, right? Then next combination could be 0, 1, 0. Right? So try that out. It's not a huge number, don't worry, right? It hardly take.
You guys think a lot.
Ah.
You do it. It will be more easier for you. If you can find out a pattern that why using 2 variables you can only have 4 combinations, then you may know that using 3 variables how many combinations you can have. Right, so that way you can think. This is a logical subject, so think logically.
We don't want output F, right? We just want to know how many combinations are there. 6. 6. How many you got? Only 4.
Only 4.
In 2 variables also we got 4, right?
6.
In 3 you 4. You stuck to 4, right? Everybody has to find out, right? I'll ask each and everyone how many you got. ટ્રુથ ટેબલ બનાવી દો 3 વેરિયેબલ. Done? Anyone? Yes? 10.
10.
Very good. 10. How many of them are repeated?
You need to
No,
check.
all are different?
Yes.
Wow.
Wow.
Excellent.
We do have Einstein here then.
Okay, let me just see. It's okay, right? It's okay to be wrong, right?
Let's write it here.
No, I'll count it. Don't worry. That's okay. This is absolutely correct. But see, I can see 1, 1, 1 and 1, 1, 1 is repeated, right? So for you, I'll just mark it down. So this is repeated. And then 101 and 101. This is also repeated. Right. So I'll remove that as well. And if I count 1, 2, 3, 4, 5, 6, 7, 8. I hope there is no repeated.
6.
Just verify yourself, right? Again. But very good, right? See, try it at least. What about you? Yes.
4. 4.
No, I got
Or increase.
6. Okay. Very good.
From 4 to 6.
6, yes.
6. Think more.
Just try to, right? It's simple game, I mean.
Is the maximum.
Output doesn't matter, right? You don't write F at all. I want only input combinations. Right? 8. Okay.
Who got 8?
8.
Please check that there should be no repetition, right? How many?
Who got 10 again?
Yeah, 10? 8.
8 or 10? 8.
So we have 2 students who got 8, right? 8 combinations. 8? चालू हो ना कर दे बने दो लो बने दो
क्या के गोटा
नहीं करो
0 1 0 1 शिफ्ट થઈ હા
चलिए ऊपर ये बराबर रखो
હા એ જ ખોટું છે હા How many combinations? 8. Sir has written it here for you. It's very simple. There is a pattern, right, that you can follow. So what you can do is, let's say I have 3 variable, right? So we have 0 1 0 1 0 1 0 1. Now this is 8 combinations, right? So this is how you can do it. Okay, now let's say I have again some questions, right? What does this indicate? Which function? AND function. And what does this indicates? OR. And what does this function indicates? NOT. Okay? Okay, so what is 1 and 0? So everyone, 1 and 0. What is the answer? 1 and 0. 0. Very good. 0 and 1? 0. 1 and 1? 1. 1. Sorry. 1 or 0? 1 or 0?
1 or 0?
You are very smart, right? You say first wrong answer is 0, they change. Okay? So this is how the Boolean algebra works. We'll continue this tomorrow morning, but what I want you, if you get a time, right? If you get a time, right? It's not compulsory. You just go through it once, right? And when you come
see,
back tomorrow,
for 2 variables you had 4 combinations. For 3 variables you had
8
8
combinations.
combinations.
So it
for
will
4, how many combinations you will have?
16.
That was the pattern, right?
Yes.
2 raised to
2 raised to the power
4. Why 2 raised to 4? Why 2 raised? Why 2 raised? See, this is where you need to understand the math, right? What if I have decimal digits? How many combination I get? Decimal digits. Decimal digits pata hai na? 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 10 decimal digits. Okay? If I have 2 decimal digits, how many combination I get? Decimal digits. I have 0 to 9, 10 decimal digits. How many input combination do I get? 0, 0 to 9, 9. So you think of this, okay? So next time when we'll meet tomorrow, we'll discuss this.
So tomorrow there will be a test.